Hey, hi, good morning, everyone. Super excited to have yet another masterclass in this sessions of masterclasses that we have here at Alma Better. Joining us today is Sayan, who will be having a class with us regarding the Instagram filters that we are using via the machine learning tools and the data that is being required. So Sayan is currently working at Walmart. He is in their data domain right now, even working closely with the machine learning and AI apps as well, right? Other than working in this sector, Sayan has also been guest faculty, not only on various segments, but even with IITs and IIMs. So I'm super excited to have you here, Sayan, and it's now up to you. And I'm pretty much hopeful that by the time we will end this session, we will have a lot of things that we would have learned about Instagram filters and how it is, using the data tools that are there available. Right. Hey, Sayan, good morning.
Hi, good morning. Good morning. Yeah. Hello. I'll just turn on my video in a minute. Yeah, hi. Hello. Hello. Hi, all of you. Hello, everybody. Once again, a very good afternoon to all of you. Uh, Afternoon now. So, uh, thank you so much for taking time out. Thank you for the wonderful introduction as well. And I'm also extremely excited to be conducting the session. Thank you for the opportunity and really looking forward to have a very engaging session with everybody. Yeah. Yeah.
We are thrilled to have you with us, Sayan. You can take this, forward now from here.
Okay, sure. Thank you. Thank you. Yeah. All right. So guys, we'll get started here, and I just wanted to clarify a few general ground rules before we conduct the session. Any general questions that you might have, I'm sure people are joining in from different parts of the country. We have a very diverse set of folks who attend these master classes typically, and I'm very sure you will have generally have certain questions. It may be related to the topic, may not be related to the topic, whatever it is. So just try to make things a little organized. Please post your questions on the Q&A portal. So that is current. That is basically something that I'll be able to see. The team will be able to see. We have Narendra, we have Rashmi, we have the whole team with us. So please post your specific questions on the Q&A section. If you have any career questions or if you have any specific questions related to Alma Better, so please structure those questions in the Q&A section, right? And that way we'll be taking it up, in serially that order. General Q&A I'll be keeping aside till at the end of the class. So we'll just to clarify the agenda once again, we will start on with a very basic introduction to what deep learning is. We'll start off with a specific subset of deep learning called computer vision, because Instagram filters are all about computer vision. Computer vision is one of the most exciting topics, I would say, in deep learning. So we're going to be looking at lots of images, lots of use cases in computer vision, and that's pretty much how we'll start our entire conversation with. And I'll be engaging you a lot. So this is not a session where I keep talking and you just listen. I always like two-way conversations. So definitely I'll be asking lots of questions. I'll be looking forward to the audience to share their thoughts, their inputs. So we'll have lots of use case discussions in the first 15-20 minutes of the session. And from there onwards, we'll be getting into the slightly technical aspects of deep learning, and we'll see how deep learning and neural networks work. So specifically, I'll be explaining about neurons. I'll be talking about what is a neural network. Okay, sorry, I think I'm not sharing my screen. Just a minute, guys. Just a minute. Just a minute. I'm just going to quickly share my screen also. Just a minute, please. Okay. Just realized that my screen is not shared. Okay, here it goes. Yeah, here it goes. I hope all of you can see my screen now. So yeah, so this is pretty much what I'll be starting off with. Use cases of computer vision. I'll be starting off with basic use cases of computer vision. And then we get into the basics of deep learning. This is the part where I start talking about neurons and what is an artificial neuron, what is a neural network. You've all heard these terms, but I'll be explaining this in a bit of detail to you. What is a neural network? And so that by the time you end the class, end the master class today, everybody would have gone away with some key takeaways, and you would have gone away with the confidence about knowing what is happening behind the scenes in deep learning. And specifically, once I complete the basics of deep learning, I'll be also entering into computer vision from a technical perspective. After we have done with the use cases, I will get into computer vision and CNNs particularly. We'll talk about a specific type of neural networks called convolutional neural networks from a slightly technical perspective. Because when we talk about Instagram filters are working. The basis of Instagram filters is a very specific type of neural networks called convolutional neural networks. And I'll be explaining to all of you what convolutional neural networks are and what CNNs basically are. A little bit of basic summary idea as to how they are working behind the scenes. Then we'll be getting specifically into types of filters and how Instagram applies filters. And as I said, much of the session will be about lots and lots of use cases, not only specific to Instagram, but similar to Instagram, there are hundreds of other applications out there. And I'll basically take some examples of other apps and other areas and other domains where similar types of filters are basically being applied. Okay. And as we go on through the session, if you have any questions, please post your questions on Q&A. We can keep the chat for a general interaction. Like I can already see that people are posting some things on chat, which is good. I would say if you have any general questions, as in when we do the topics, you can put it on chat. Otherwise, put it on Q&A. Yeah. Okay. Wonderful. Okay. Great. So I think let's get started here. I think the team already introduced myself very well. Thank you for the wonderful introduction again. This is a small LinkedIn profile about myself. I think this is what I do again, and I work for Walmart and I do consulting. I also am a visiting faculty with several of the premier universities, and I'm also a very active part of Alma Mater in terms of the programs that we do. So whenever an opportunity comes up, I'm really thrilled to be part of the master classes. And it's just an amazing opportunity for me to teach in these master classes. And I also take sessions at Alma Beta. Whenever there are some niche requirements, I do engage in sessions also, specifically on some of the advanced topics. But that is basically my association generally with the organization. And super excited once again to be interacting with all of you. Okay. Now, let me engage the audience a little bit. My first question to the audience is, because a large part of our session is basically on this entity called computer vision. Okay, so what is computer vision? Okay, what is computer vision? We've got a good amount of, let's say, 50, 100 odd participants in the audience today. So what do you mean by computer vision? Anybody wants to put forward an answer quickly? How do you explain computer vision? Okay, Siddharth has given an answer. Great, Siddharth. You can post it on Q&A, the chat section. General questions, general interactions, let's put it on chat. Okay, ability of computer to recognize an image. Okay, what else? Anybody else wants to frame it in a different way? What do you mean by computer vision? Computer vision. What is computer vision? Okay, detect and classify objects. More technical term you have used, but what is it generally? A technique through which computer can recognize an image or any objects. Yes, it's an application of machine learning. Absolutely right. Yes, analyzing of digital images. Okay, may not be only images, by the way. It can be videos also. And just to clarify right up front for people in the audience, videos are also just like pictures. It's not that videos are something different, pictures are something different. They're two different types of data. Yes, computer vision, it involves analysis of videos also. So absolutely, the most basic example of computer vision could be exactly how a computer sees anything. It's a very, very simple example. Yes. It is the ability for a machine or a computer to see and process things. That's computer vision. Think of human vision. What is vision? What do you mean by vision? When we say human beings have vision, what is it? See, you have eyes, right? We all have eyes. We can see things. That seeing is not vision, okay? Even a person in a coma state can see something. Eyes are working. You're able to see something. But vision is where you are able to see and process the information. The information goes to the brain, you're able to process, and that's perception, as Siddharth rightly mentions. That's vision. That's why a person in a coma state, although they can see everything, but they're not able to understand anything because they can't process the information. So computer vision is the ability for a machine to see and process things. See, otherwise we have a camera, right? I can take a camera, I can take a picture, That's also vision. That's not vision, by the way. If I simply take a static photo, that is not vision. That is a simple picture. Camera per se does not have vision. Camera is only able to capture a picture. That's it. Camera is only able to capture the photo. It's only seen. What you can do is you can take that photo, you can put it into a software like a Google Photos or some other image processing software. And if you're able to process and extract some meaningful information out of that image, that is what we call computer vision. And that is pretty much the whole idea of what is happening behind the scenes in all the filters and everything that we're discussing today, where you're not only taking a picture, but you're also processing and perceiving that picture in a different way. That's computer vision, deriving a meaning out of it, correct? So if you're able to give machines the same perception of a picture that humans have, that's computer vision. There are lots of applications of computer vision, and what I will do right now is to engage the audience in a big way and talk a little bit about some of these beautiful applications. And obviously, in line with the masterclass we are doing, one very common application of computer vision is filters. Now, Instagram filters, Snapchat filters are very popular applications, I know, and the ideas are very similar. Where I'm sure people in the audience, many of you would have used Instagram, many of you may not have used Instagram. Personally, I'm not too much into social media, but I have used Instagram to some extent, not in a big way. But then the idea is that you take a picture. It happens a lot on the mobile app. Even the desktop application has some capabilities, but mostly the filters are there in the mobile app. The mobile app gives you more capabilities in terms of filters and image editing functionalities. You take a selfie or you click a picture, you want to post something on Instagram. Instagram allows you to basically modify the picture in different ways. Look at this thing. You take a normal selfie, and typically at the bottom, these options will come. You can basically make yourself wear a glass. You can basically put some small sparkles around your face. All those kind of things you can go back and do. So how you're able to take a picture, so how you're able to go back and take a picture, and how you're able to transform the picture in different ways. That's what filters basically do. And this is not only with respect to Instagram. This is there in Snapchat. And hey, how can we forget that very popular app called Face App? Face App is also a wonderful application we can talk about. Face App. I'm sure everybody knows and recognizes Face App, where we know how Face App is able to use neural networks to change your entire look and feel. Just going to refresh the page and show you. Okay, so see how Face App is able to change your entire look. I'm sure everybody would have used Face App at some point in time in your life. These are also using filters. So you can go back and take a picture of a person. You can go back and take a picture of a person, and you can make yourself look different things. You can make yourself look old. You can put a lipstick on your face. You can make yourself look like a female. You can make yourself look like an old person. It's completely using filters. So filters are an extremely powerful concept in deep learning and computer vision, where you're able to process and create an entirely new image out of it. Okay, I'm sure everybody has used Face App, and Face App is almost scary. Like some of the results it gives you is almost very scary. Like sometimes you can literally go and see how you would have looked like 10 years back. Remember, Facebook came up with this thing, 10 years younger, 10 years younger. How there was that challenge that Facebook put out. Everybody started posting how they looked 10 years younger, how they looked 10 years older. And the surprising thing is that the really incredible thing about computer vision is machines are, even if you look very different, certain basic attributes of a person's face remains very similar. Although you're putting some more hair, although you're putting a lipstick on your face, although you're putting some wrinkles on your face, all these things are happening, right? So this is a completely changed person. Like honestly speaking, if you ask me to say, is this and this the same person? I'll say they're not, obviously. Like, but machines and powerful computer vision algorithms will still be able to look at these two pictures and say, hey, they're the same people. We have simply added some image modification effects on them. You know why? Because certain basic attributes of the person's face remain the same. When I say attributes of the person's face, I mean the eyes, the ears, the small pixels around the person remain the same. The alignment of the pixels remain very similar. Because what is a picture? When we talk about a picture, what is an image? An image is nothing but a collection of pixels. You please go back and look at what is an image. An image is nothing but a collection of pixels, right? That is what an image actually is. So the whole idea is how we go back and play with those pixels. If you're able to modify those pixels in a certain way, you've managed to generate something. Okay. All right. Now let's talk a little bit about the applications. As I told you, I'll be getting into some applications of computer vision particularly. We are starting off our discussion with computer vision particularly because that's the real key topic of our session. I'll be getting into some other areas also, speech recognition and NLP. Have a brief discussion because all this is basically part of deep learning. Everything that we are basically doing in the session today, the superset is basically deep learning, and deep learning is basically a slightly advanced branch of machine learning where we are trying to learn more complex patterns of our data. You're giving the machine lots and lots of input-output combinations, and the machine is learning something out of it. You're trying to learn some more complex patterns out of the data. That's deep learning. I'll get into more technicalities in a while. Okay, so what are some applications of computer vision? Let's talk about a few applications. Now, one thing that came out very well from the audience is image classification. That's the most obvious application. I think one of the best applications of computer vision will be Google Photos. And what is Google Photos basically doing? Quite incredible. What Google Photos is basically doing is we look at a picture. Okay, let me just give me a minute here. Okay, let's see. Look at this one, all of you. I have basically searched for elephants on the screen. Look at this. So I basically went to the search bar and I'm searching for elephants. Okay, I went to the search bar and I'm searching for elephants on the screen right now. I'm basically typed elephant. So what is Google Photos doing behind the scenes? This is already a trained deep learning model. If I have to talk about this a little bit more technically, Google is learning the same way kids learn. Imagine you're teaching a small kid about fruits. Okay, now how does a small kid learn about fruits? Imagine you're a very small kid and it's your very first day in the kindergarten. You're going to the school or the kindergarten for the very first day, right? And on the very first day, the teacher is trying to teach you that, hey, what's an apple? What's an orange? What's a watermelon? The teacher is teaching you different types of fruits today. Okay, so the teacher will be teaching you about different types of fruits today. But hey, pictures like this are apples. Pictures like this are oranges. And pictures like this are watermelons. Pictures like this are apples. Pictures like this are oranges. Pictures like this are watermelons. The kid will not know what is an apple unless you teach it. So the teacher is showing a particular type of fruit to the kid. And the teacher is saying that, hey, exactly, Preeti. The teacher is saying that, telling the kid that, hey, here goes a fruit in front of you. Look at the fruit, please. So here goes the fruit in front of you. I'm going to quickly open up my whiteboard for a minute. Okay. Good to see people are so active. Yeah. Please keep responding. Okay. That way it really feels engaging. Imagining the image of an apple in mind. Well, correct, Vittal, that will eventually happen, but that's after some training. The kid will initially not know what's an apple, but after you train the kid sufficiently well, the kid will start recognizing that, hey, this is an apple. Correct. So on the very first day in the kindergarten, the kid is basically taught this, that, hey, fruits like this are called apples. The teacher will show the kid different types of fruits, right? Fruits like this are also called apples. This is a slightly, I think, side view. A side view of an apple will probably look like this. Okay, I'm very bad in drawing pictures, so please don't laugh at me. So so this is also an apple. It's a side view. Okay, it's a side view. The teacher will now start to teach that, hey, these are oranges. So this is orange. Okay, this is orange. And this is your input-output combination. That's your input data, input picture that the kid is seeing, and that's the output label that the teacher is teaching the kid. Kids learn on the basis of input-output example data. This is actually called training data in machine learning. Oftentimes in the world of machine learning, this is referred to as training data. In the world of machine learning, we often refer to this whole thing as training data. So you show the kid lots and lots of examples of this training data. The machine tries to learn the patterns on the basis of this training data, and it builds a model. So we show the machine lots and lots of XY combinations, input-output combinations. The kid tries to learn the patterns on the basis of training data and builds a model. And now the kid has understood that, hey, the teacher taught me like this, that, hey, when the kid was like this, it was called an apple. When the fruit was like this, it was called an apple. When the fruit was like this, it was called an apple. When the fruit was like this, it was called an orange. Next time I show you a completely different kind of fruit, what is that fruit called? So fruits like this are called apples. Fruits like this are called oranges. Next time I show you a completely new kind of fruit, what is it called? That's machine learning. That's what we refer to as machine learning or deep learning. Deep learning also works on the same principle, just that it's a bit more advanced. So similarly in Google Photos, the same idea is working out. If you see, how did Google know that this is called an elephant? How did Google figure it out? So Google would have been trained in the exact same way. We have taught Google in the exact same way. We have shown Google. In fact, Google is having a huge repository of pictures in it. There are hundreds and thousands and millions of pictures in the Google repository. And Google has learned the patterns just like that small kid that I showed you a while back. Google has also learned the patterns based on the historical training data, the example data. Objects like this are elephants. Objects like this are elephants. Objects like this are tigers. Objects like this are lions. And objects like this are rhinoceros. These are different types of objects we have right now. Okay, so objects like this are elephants. Objects like this are elephants. Objects like this are not elephants. We have trained Google on the basis of the historical data, and we have taught Google what elephants look like and what elephants don't look like. And with enough amount of labeled data, enough amount of example training data, Google would have learned, it would have built a conceptual model. Just like Vittal said, it has now started figuring out an image in the mind. It started to figure out the patterns that, hey, this is what I was taught, that pictures like this are elephants and pictures like this are not elephants. And now I know what elephants look like. If you show me an entirely different picture, I can predict whether it's an elephant or not. So now when I go back to and click a completely new picture, and if I search for elephants here, you can see that Google is able to very accurately predict that, okay, these are elephants. These are also elephants. Surprisingly, in the world of machine learning, machines can also make mistakes. The same way that in Instagram filters, sometimes the filters can go wrong. You've seen, right? In Face app, oftentimes the hair comes like this, the hair comes a little bit here. Errors happen in machine learning. This is the reason is because machines can often make mistakes. Tesla cars will oftentimes crash because sometimes whatever the machine has learned is not always foolproof. The machine can often make errors and mistakes also. The same thing is happening here also. So the Google has learned on the basis of the historical training data, but whatever patterns that Google has learned, it is not guaranteed that those patterns are absolutely correct. You can see a great use case right now where the patterns are not, sometimes the patterns are not learned correctly. You can see here the patterns are not learned correctly. So this is the intuition that we're able to see. All right, wonderful. Now let's move on. I wanted to give you one more very beautiful example of this error in machine learning. That's another discussion altogether, but I wanted you to be very, very clear about one thing, that it will never be 100% accurate. Machine learning models will not be 100% accurate. Like, for example, we are talking about image classification. So image classification will, so all these machine learning models will never be 100% accurate. So the models will never be 100% accurate when it comes to testing. Okay, there'll be errors that will always happen. Yes, you cannot say that. Anangsha, just to answer your question, you can never say that the model will be 100% accurate. It will never be. Now the whole idea is to identify thresholds. You are trying to identify thresholds and you're saying that, hey, now at what point do I say the machine is reasonably accurate? Okay, so reasonable accuracy depends on your expectations. Okay, Google Photos is not a very, an absolutely like a do or die kind of an application. Even at times, if Google is making errors, is fine. Like, for example, you can see I'm searching for snow. Pictures like this correspond to snow. Pictures like this also correspond to snow. Model is doing it very correctly. See how beautifully it has learned the patterns. Snow can be, but here the model has made a mistake. Google says that this is snow. This is wrong. It's wrong. This was a picture I took on the flight. It's actually clouds on the air. not snow. So this is the scenario where Google has made a mistake. So patterns like this correspond to snow. Patterns like this correspond to snow. Patterns like this don't correspond to snow. This is not snow, but Google somehow says this is snow. This is the error. The only way to make it correct is to give it more training data and to make the model learn a little better. This is the constant iterative process in machine learning or deep learning. So even if the machine makes errors, even if the machine makes mistakes, even if the filters, the Instagram filters are not working to the extent that you want them to, the important part is to go back and try to take some more data, sample data, and try to retrain it and make it work better. But you will never get 100% accuracy. Okay, yes. There was a question by Siddharth. Siddharth, I didn't quite follow your question. You said machines can only learn, but can it have its own meaning attached to the object? I think the question is a little vague. If you can just put it, it's a little ambiguous. If you can just put it on Q&A, I can, or consciousness. Okay, consciousness. I think you're taking it to one more level. You're talking about neural link and things like that. If you're talking about it, yes, that's another excellent application of computer vision, we can say. I think we already have great progresses happening in the space of dream analysis and all that. I'm sure people have heard of Neuralink, human-computer interaction Neuralink, where we can basically analyze the brain signals and you can literally predict or you can literally estimate what is the person thinking. Maybe a few years from now, we will be in a position to completely decipher a person's dream. And we know dreams are an entirely different thing. It's right bordering on consciousness and subconscious mind. So we do have the technology today, where you can go back and figure it out. Yeah, absolutely. Okay. Okay, wonderful. This is just one part of what I wanted to talk about, classification. I wanted to start the conversation with a classification model, something that people answered, where we look at a picture, we look at an object, and we try to classify what is the object in the picture. We are trying to figure out what is the object in the picture. That's classification. Okay. We also have something called localization. This is one more type of computer vision problem. Coming to the use cases, we also have something called localization. What is localization? Localization basically is about identifying two things. We are solving two types of problems. One, we are trying to figure out what is the object in the picture. And two, we are trying to figure out where is the object in the picture. That is what we are trying to do in localization. In localization, we are solving two problems. One, we are trying to figure out, hey, there's a cat we are seeing in the picture. Okay, so first we are trying to figure out what is the object in the picture. And two, we are trying to put a bounding box and trying to figure out where is the object in the picture. So two problems we are solving. A, what is the object? B, where is the object? You're putting a bounding box around the cat and you're saying that, hey, this is where the cat actually is. Now, localization is about individual objects, single objects. But in more practical use cases, we do detection. Detection is basically about multiple objects. This is what we see a lot more in real-time applications. I'll talk about lots of applications here as well for you. Object detection is when we take a sample picture, we take a random picture, and we try to identify where the objects are and what the objects are. So where are the objects in the picture? We are able to see 4 objects in the picture right now. And what are the objects in the picture? So cat, dog, and duck. So A, where are the objects? And B, what are the objects? I repeat again, there are 2 specific problems we are trying to solve. So A, we are trying to figure out where are the objects in the picture. And B, we are trying to figure out what are the objects in the picture. Okay, so A, we are trying to figure out where are the objects in the picture. And B, we are trying to figure out what are the objects in the picture. So we are looking at a cat, dog, and duck. Detection has lots of other use cases. I think if you look at the modern day smartphone cameras, I can take a picture. I can basically take a picture, and what we can do is the detection models are inbuilt in the camera app. And wherever it sees faces, it will automatically put bounding boxes around the faces. Detection has been a very old technology, starting right from the era of Facebook. Ever since Facebook started, we had photo tagging. All of you remember? Photo tagging used detection technology. So you look at the picture, you identify where are the objects in the picture, where are the faces, and what are the objects in the picture, who the people are. Face detection photo tagging work the same way. So you take a picture and you're trying to tag the photos in the picture. So what used to happen was you took a picture, and Facebook automatically put bounding boxes around the faces. This is the face, this is the face, this is the face, So Facebook automatically started putting, bounding boxes around the faces. Here goes the face, here goes the face, here goes the face, and all that, right? So Facebook automatically started putting, uh, bounding boxes around the faces, and it started solving two types of problems. It tried to figure out what are the so A it tried to figure out what are the objects, and B, where are the objects? So first, where are the objects? So please put a bounding box where the objects are, where the faces are. Wherever you see a face, please put a rectangular bounding box. So all the faces were highlighted. And when you hover over a particular face for tagging, Facebook automatically started to show you that, hey, do you want to tag this person? That is classification. So in detection, you're doing two things: identifying where the faces are, or where the objects are and what the objects are, who the people are. The same thing also works in modern day smartphones. You take a photo and automatically the faces are highlighted. It has enormous applications in, I would say, surveillance and security use cases. If you look at all the CCTV cameras, city planning, airport security, railway stations, all the public areas, detection technology is extremely popular. I think we've seen all the movies and all, right? In the movies, typically they show you the security officer analyzing the surveillance footage. Yeah, I think we've all seen detection. Those rectangular bounding boxes coming. Object tracking kind of things are being used. These are all happening in practice. Again, a great application of computer vision entirely. Okay, so uh, finally, we have something called segmentation. Now, what is segmentation? What is the basic idea behind segmentation? Segmentation is one more type of computer vision problem. Segmentation also, we are doing something very similar. We look at the object and we try to figure out we look at the image and we try to solve two problems again. A, we are trying to figure out where are the objects in the picture. And two, we are trying to figure out what are the objects in the picture. So there are two problems we are trying to solve. So A, we are trying to figure out where are the objects in the picture, and two, we are trying to figure out what are the objects in the picture. Okay, so that's how we are actually going about it. Okay, so A, we are trying to figure out where are the objects, and two, we are trying to figure out what are the objects. So A, where are the objects in the picture, and two, we are trying to figure out what are the objects in the picture. So where are the objects you're not putting a rectangular bounding box here. Rather, you're putting an exact boundary around the object. So you see an object here right now, you put an exact boundary around the cat. You see an object here, you put an exact boundary around the cat. You see an object here, you put an exact boundary around the duck. And you see an object here, you put an exact boundary around the dog. So you look at the object and try to put an exact boundary, identify where the object is, and identify what the object is. That is segmentation. Now, you might ask me that, sir, why is it so important for doing segmentation? I'll tell you what. Detection has a lot of great use cases. If you look at detection is extremely common in today's world. There are lots of applications. I'll come to some more applications in the course of the next 10, 15 minutes more. I'll talk about applications. I'll talk about some more. Even if you look at healthcare also is like a lot of detection models are there. Bounding boxes, we have seen a lot of use cases typically, right? But then segmentation is extremely hard. Segmentation is also very costly because you're trying to be exactly sure where the object is. That is not a use case for Facebook, right? When Facebook started photo tagging, even today, if you try to tag a person's face, Facebook doesn't use segmentation. Facebook uses detection technology. You hover over the face of a person, and around the face of a person, Facebook is not drawing the exact contours of the face. Facebook is only drawing a rectangular bounding box. It suffices the needs. It doesn't have to be absolutely accurate. And remember how I said that machines can be wrong? And we know that oftentimes in photo tagging, you hover over a face and it doesn't show the face. Sometimes the rectangular box doesn't even come. That is the error in machine learning, or the error in deep learning, we can call it. ML and DL are the terms I'm using interchangeably, right? But then where does segmentation apply then? Segmentation comes in very, very handy in applications like self-driving cars, where you want to be exactly sure what the contours of the object actually are. I'm going to give you a very small, a quick example so that people can relate to this a lot better. Look at this, all of you. We're looking at a small application of self-driving car. See this, all of you. We're seeing a simple, application right now. And if you see, look at this image, all of you. This is what a typical self-driving car will see. You have an image in front of you. There's the camera-mounted car that we have. The camera is mounted on the roof of the car, and this is the image that the car is seeing in front of it. it's very important for the car to know exactly what the contours of the objects on the road are. You cannot say that, hey, there is a bounding box around it and this is the car. No, because the rectangular box can be inaccurate. If I say, hey, there is a person here, I want to draw the exact shape of the person. That's segmentation. I'm not okay with a simple rectangular box because the rectangle will be inaccurate. It will not cover the entire shape of the person because the car has to navigate around the whole person, right? It has to automatically drive. See, I cannot draw a rectangular bounding box for the footpath. These are practical limitations of a detection model. So whatever application we are seeing detection cannot happen for these kind of cases. See, for example, sky. You can't draw a bounding box around the whole sky. You can't do that. It will be a big rectangle, right? You can't draw a bounding box for the entire tree. See, these are the pixels for the tree, right? You can't draw a bounding box for the whole tree. You cannot do detection for this kind of things. You want to be exactly accurate. There goes segmentation for you. Another very common application of segmentation will be this. I hope people can see my video how it changed. See what has happened here. Okay. I can take a different picture and show you. Save image as, and let me just have a little fun here. So whatever WebP file or whatever, right? Exactly, blur. Correct. Absolutely. So we have some file, and I can basically go and choose any virtual background. I can go and choose any virtual background here. Okay, I can go and choose any virtual background, and what will happen is automatically that particular virtual background will occur. Okay, I can go and choose any virtual background. Let me see if I have a good picture to show you. I know we're discussing about machine learning, so I can just quickly open up the machine learning workflow. This is a bit of a different image I'm showing. People can see, right? Can you see? There goes segmentation for you. So this is a classic example of a segmentation model. Imagine how poor the thing can look like if I did detection. Detection is what? Detection means that it puts a rectangular bounding box around me. But then if I form a rectangle around around the face, see, look at my hand. Even my fingers are separated very correctly. The contours are coming very accurately. If this was a segmentation detection model, then it will put a rectangular box. See how beautifully the background is coming now. I'm actually showing the slightly technical topic at the background, machine learning, training, testing, and all that. That's not the intent for today's class, obviously. But this is segmentation once again. These are applications where segmentation comes in handy. You are trying to identify the exact shape of the object and tell what the object is. Segmentation also has great use cases in the world of, I would say, medical healthcare use cases. Medical use cases. Take a situation where let's say we have a person who is suffering from bullet injuries, internal injuries. The person who is hit by a bullet or some kind of internal injuries happened. Okay, you take an X-ray of a person. In fact, the whole domain of radiology. Radiology, I hope people know. Radiology is basically that branch of thing where we're dealing with medical imaging. You're dealing with images of the human body. X-rays, CT scans, MRI scans. You take a picture of the person's body and you try to make diagnosis out of it. Next time you do an X-ray, the X-ray is basically handled by a team called radiology, a department called radiology. Radiologists are people who basically analyze X-rays. They're experts in analyzing X-rays. Oncologists and all, they do the same thing, right? They look at an X-ray and they try to figure out cancer and all that based on that, right? So imagine a scenario in the healthcare space where we look at the X-ray of a person and we try to identify where the shrapnel is in the person's lung. Because let's say the person is hit by a bullet and there is some shrapnel, and you want to help a doctor. You want to assist a doctor to identify the shrapnel in the person's lung. How do you do that? Again, segmentation model will come in very handy because you want to be very clear. You want to be very specific about the shape of the shrapnel, where the shrapnel is, what are the contours of the shrapnel. We are not talking about replacing doctors. I think one general argument that typically goes around in the world of AI ML is that, hey, can we go and replace doctors? We're not talking about replacing doctors. Doctors, radiologists, human beings will never go away. But how can we make AI augment their functions? How can we make AI help them perform better? How can we optimize and how can we make them more efficient? Instead of a human being manually looking at X-rays and try to figure out things on the basis of that, how can we make human beings do this? That's one way to look at it. So how can we assist doctors to do this better? How can we assist doctors to basically do their job better? So the algorithms can analyze the X-ray of a person, and it can try to figure out what is the shape of the objects, what is the shape of the objects, and where the objects are. And then the doctor will be in a better position to extract those shrapnel out. Yeah. Segmentation is detection for accurate bounding of objects, correct, with exact shapes. Detection is more like rectangular bounding boxes. Segmentation is more accurate shapes you're doing. Vital, just to clarify, at a slightly more technical level, although it's a bit of a technical discussion, at a slightly more technical level, all that we are doing in a segmentation model is we are doing pixel level classification. We are trying to basically classify each and every pixel. So if I say this is a 100 cross 100 picture, imagine this is the 100 cross 100 picture. That means there are total 10,000 pixels we have right now. All that we are trying to do in a segmentation model is we are trying to classify each and every pixel. So we have 10,000 pixels and we are trying to take each and every pixel. Let's say these are pixels corresponding to trees. These are pixels corresponding to sky. These are pixels corresponding to person. These are pixels corresponding to cards. That's what's happening behind the scenes in a segmentation model. Okay, so there goes segmentation for all of you. What segmentation actually refers to. These are the four very generic types of computer vision problems that we have. Classification is the most common. There are tons of examples of classification where you look at a picture and you try to classify what is it, like Google Photos, like X-ray analysis, lung cancer, right? You look at the X-ray of a person and you try to predict whether the person is suffering from lung cancer or not. Okay, you look at the X-ray of a person. Okay, look at this. Assisting pathologists in detecting cancer with deep learning. It's a wonderful, link. I wanted to quickly ping all of you. You can look at all these things as we go along the sessions, right? Assisting pathologists in detecting cancer with deep learning. So how do you go back and look at a tissue or radiologists in detecting cancer? Look at a cellular level data or a X-ray of a person, MRI scan of a person, and how do you go back and diagnose whether a person is suffering from a particular kind of cancer? So a lot of medical diagnostic use cases are there. You look at a cellular level data, and how do you use computer vision and segmentation models to basically analyze tumor probability? Look at this. This is incredible. These are some incredible applications of deep learning that we are able to see. Specifically computer vision. And wherever the tumor is coming, see how the model will automatically color it. There goes segmentation for you. Okay, so you're able to color exactly those portions where the tumor is present. And now the doctor will be able to better perform surgery on those regions. Our algorithm successfully identifies the tumor region and is not confused by the macrophages, which is again a bit of a technical term. Okay, so you can look at it, and this way, a lot of advancements have happened in the field of this thing. We can also talk about one more great use case. People can go back and use it as we speak in the after the class today. So we have an app called Skin Vision. Okay, very interesting. Skin Vision is used for diagnosing skin cancer. See what it does. You can take your smartphone. You can take a picture of your skin. Let's say there is a particular spot on the skin that you see. You can just take a picture of the skin spot, and automatically the model will identify whether you have skin cancer or not. See, sometimes moles in the skin are very bad. Like we humans, we tend to ignore all types of problems until it comes to the last minute. Unless we see a symptom, we just ignore it, which is actually not good. We should always diagnose. We should always do testing. Skin vision is a wonderful application. The skin cancer is actually very hard to detect. And see, we all get moles in the skin. Some mole is coming, something is coming. We tend to ignore it. But melanoma is very common actually. Skin cancer is very common. And uh, if you think from a practical application perspective, it's very difficult to all the time visit a doctor, go to the clinic, perform a costly diagnosis. Rather than that, wouldn't it be incredible if I can somehow take a wouldn't it be incredible if I can somehow take a picture? I get a mobile app right at the comfort of my home. I get a mobile application. Excuse me. And I take a small picture. I take a small picture using my mobile application. And based on that, it's able to figure out whether it's skin cancer or not. This is completely using a classification model. So what is it doing behind the scenes? It is taking a picture and it's predicting whether it is skin cancer or not. Okay, classification. Again, skin vision is again a great use case we have. There are tons of use cases. I'm trying to talk about a few general ones. This is basically in the domain of healthcare. Any kind of medical diagnostic use cases, even during the COVID period. If you remember during the coronavirus, the COVID period, lot of wonderful applications started coming out in this field. Okay, we had X-ray of a person, and based on that, the models try to predict whether the person is suffering from COVID or not. We had some wonderful use cases coming all through COVID. Here goes one more excellent application of segmentation. See, like how we are able to form the exact shape of the object. Okay, again, what is happening at a technical level? At a technical level, we are doing, a pixel level classification. We are looking at each and every pixel of the object, and we are trying to classify each and every individual pixel. So that is what we are trying to do at a technical level. There are more interesting applications of computer vision, and I'll be talking about a few of that. One is very common. We have something called super resolution. Computer vision and deep learning are also incredibly used in the world of photo editing. I'm sure you have seen these kind of applications every time. So you have got all these super resolution, image processing softwares where you upload a picture in a low resolution, and the algorithm is able to automatically upscale the picture to a high resolution. You get higher quality images. Another incredible application of deep learning is style transfer. And I show a real-time demonstration of style transfer for all of you. What is style transfer? It is basically applying the style of one image onto another. So there are two things. Let's say, look at this one. So these are two images that we have. How can we take image one and image two, and how can we generate a third image? So there are two broad technical terms we have here. So one, we have the content image. The content image is the main image that we are referring to. So one, we have the content image. The content image is the main image that we are referring to. And two, we have the style image. Right? I repeat again, we have basically two different types of images. We have something called the content image. The content image is the main image we are referring to. And then we have the style image. The style image is the theme or the style that I want to apply to my main image. So when I combine the two, I get a completely new image. So style transfer is a process of creating a new image with the content image and style of another image. Okay, I think it will be better if I show a practical demonstration. Let me quickly open up a Jupyter notebook using which I will show a practical demonstration of style transfer to all of you. Something very interesting we are doing. All of you can see the screen. I think my just going to take a minute to reconnect. So what we'll try to do here is we will take the content image, which is that of the tortoise. Okay. And we will basically go back and take the style image, which is this one. This is a very popular painting. Okay, while I show this demo, let me also parallelly run the code because I think I actually did execute it. But what happened is because there was some idle time, we already spent, I think, some 50 minutes in the class. The Google Colab actually disconnected. Colab is basically a Jupyter notebook platform for executing code. I don't want to scare people with coding right now. This is not the agenda for the class at all. But I still wanted to go above and beyond and show you something a little cool. Okay. But don't worry about all this. But I wanted to show you something running real time. Okay. Let me run this and I'll explain to all of you what it is, what we are doing here behind the scenes. This is actually the content image. The content image is that of the tortoise. And what you're seeing here is a style image. The style image is that of a very famous Japanese painting called the Great Wave of Kanakawa. So here we have the tortoise, the picture of the tortoise. This is the style. This is the main content that I want to use. The right-hand side is a style image. So you want to apply this particular styling to this picture. And what is the styling? The styling is basically, the style is nothing but the Great Wave of Kanakawa. It's a very famous Japanese painting. And when you combine these two, you end up getting this. And this is the work of art. We've all heard of these things, right? AI generating art, AI generating paintings. Here goes a practical application. You can give it anything. I will demonstrate something with my own selfie. I can take my own picture right now, real time. I'll show you something with this. Really cool. Really cool. Okay. So you can take any picture. You can take your own selfie. You can take any picture and you can put any style and the content will be your own selfie. The style will be something. It can be this. It can be Mona Lisa painting. It can be some other theme, some other sky theme, something. And you can integrate the two and you can create something magically different. You can have your own selfie looking something different in a different style. And there goes a work of art for you. So all these applications, they're all using a simple style transfer piece of code and they're marketing them as, so incredible applications we are seeing in the world of deep learning. See, this is the model training happening. Don't want to get too technical into this topic right now, but you can already start to see how it's happening. The model is still training. And after the iterations, you can see how the loss is reducing. You can see this is one more iteration that happened. It's completed 700 epochs right now. And you can see after every epoch how the model is basically getting trained. Okay, 800 epochs are completed. And I think instead of waiting, let me also take a sample picture of myself so that I can also show you real time how style transfer is happening. Style transfer also happens very popularly in Face app. Face app, you can also do the same thing. I'm sure you have seen that feature where you can take your picture and you can basically use your own picture as a content, and the style can be something else. You want to see yourself in, let's say, Hrithik Roshan style or Shah Rukh Khan style. Face app has that feature. What is it doing? It's doing style transfer. You have your own picture, which is the content, and you want to combine your own content, your own face, and you want to see yourself in Shah Rukh Khan style. So style transfer basically. So it's incredible applications. Here we are taking a simple demonstration. But what I can do is I can basically show this to you in a slightly different example also. We can see one more example as well. So let me just show you. So on one hand we have, this is one more example I'm showing you. So all of you can see. So this is the I'm just going to quickly show you these two pictures and then show you the resultant result, how it's happening. This is one more example. So this is the content. The content is nothing but the Tübingen Neckar front. This is the content image. And the style image is basically this Van Gogh Starry Night. These are two sample random pictures I've taken. So I want to basically see this particular picture in this particular style. So I want to basically add this particular style to this particular picture. And when I do this, see how it is working. See how the main content still remains this Neckar front, and see how I'm adding this Van Gogh Starry Night style on top of this. Incredible. I'll show you one last demonstration using one of my own selfies. Okay, let's see this one in action. This is actually working, iterating through multiple epochs to make it even better, even better, even better. You see how it's working out. Take my own picture. So I'll just upload the photo. So this is my photo. This is cyan.jpg. I can just quickly open it up, and this is how it will look like. It's one of my pictures, right? So this is one of my sample photos I've uploaded here. And what I will do is I'll do style transfer. So so what style I want to look at? I think I want to see myself in uh, which one? Which one, guys? Great Wave of Kanakawa style, because I like that painting. So I'll quickly just go back and just create a cell. So the content image will be cyan.jpg. I'll just make an edit. The content image will be cyan.jpg, and the style image will be the Great Wave of Kanakawa. The Great Wave of Kanakawa.jpg. There goes the style. There it is. I can run the code. Let's see, a couple of epochs will work out. And we'll see how it goes. Sorry, okay. Oh, I think, sorry, I made a mistake. I think I just already executed. Let's see. This is the first epoch, nothing happened. Second epoch, you can see 0 iterations, no loss happened. Then slowly, the Kanakawa style will start coming to my picture. Look at this. Now, I was not the best example I'm taking, because my face will be hardly visible after a while. But you can start to see how if you take a different bit of a selfie kind of a face, it'll look a lot better. It'll look like an entirely different. Yeah. No, not an inbuilt function. I actually wrote a lot of code to make this work. Yeah. So there's a lot of things. Technically, there's something called content loss, style loss. A lot of things are happening behind the scenes to make it work. Yeah. All right. Wonderful. Just gonna wait for this to complete. Not really, Vital. Limit iterations, not really, because iterations are nothing but epochs. You can have as many epochs you want. Iterations are not really limited in any way. The number of epochs are not really limited in any way. You can have any number of iterations or epochs. Yeah. After a while, there'll be no meaningful change you will see, because if you already have trained a model up to some extent, beyond the point there'll be no change you will see, because beyond the point there'll be no impact you will see. That's the only thing. Yeah. It's a bit of a technical topic, Anangsha. So, what are epochs? What are iterations? Epochs are basically nothing but how many times you're doing, like, okay, so it's like steps. I'm just going to use a very non-technical term. It's nothing but steps. How many steps you're performing? So here I performed 1,000 steps. Specifically, I performed 900 steps to get to this point. So 900 times I'm basically doing some processing on my picture to reach this point. Yeah, yeah. Okay, all right, all right. Here I wrote the complete code, but there are libraries that we can also have. Yes, absolutely. You can add the iterations as a number. If you want to specifically see how I did that, again, it's a bit of a technical topic, but then I can show you. See this part? For I in range 1,000, I did this thing. So we basically ran this model for 1,000 epochs. Fine, Vittal, you can actually do this. So for 1,000 epochs, I ran this thing. So yes, you can actually hard code the number of times you want to run the code. So 1,000 times you're basically running a for each loop, and 1,000 times you're basically applying the same set of pre-processing on the picture. Okay, wonderful, wonderful, great to see some real examples actually. Okay, and I have so much fun showing these things, because we actually get to see some really cool stuff. Okay, okay. What are some other applications? We have object removal. This is a wonderful use case. I think this is something that even Google Photos incorporated in their latest update. We have seen photo object removal in other applications also. Very interesting. Again, a wonderful application of computer vision. Not always accurate, but still works pretty well. Where you take a picture and you put a circle or you put a box around some object, and automatically the object is removed from that. Okay. So object removal is also a very good application, where you take an object and you put a small box around the object, and the object is removed. You can see there's some error that is also happening. So the object is removed, but there is some small patch that is actually formed. See, the object, the lady is removed, but there's some small patch that is formed. Okay, so people do these things a lot. No, you go to a particular holiday spot, you take a picture, and then like you want to see that, hey, you are alone in that amusement park. No, you remove everybody else and you see yourself. So even Google Photos in the last update, I think if you're part of Google One, the last update, Google One has actually you can use the premium feature of object removal. So they have incorporated that in the current one, but this was already there in other apps. Other apps, if you have a Samsung phone, Samsung phones and all, you can do object removal as it is, right? I'm sure people have seen this. If you want me to, right? Yeah, inbuilt function in Samsung A73, S21 Ultra, all these things, it's already inbuilt. You can draw some section and automatically it happens. Face recognition, we talked about it already. This is internally using object detection, and image enhancement is something we also talked about, like the resolution, GANs, and all that we talked about, right? Resolution. Okay. Now then, we'll talk about a few other use cases and then get to the technicalities of deep learning. All this while we are talking about lots of use cases, and now we get to the next phase of our conversation as to how these things are actually happening in practice. Okay. But before we get to that, a few other really cool use cases of computer vision I'll be getting into. So we actually have something called text to image generation. This is a slightly more advanced application of computer vision. Really cool, really advanced. All this while we are talking about cases where you have a picture and you're trying to classify what is the picture. Is it an elephant, or where is the picture? All that we are trying to do. What we are looking at right now is something absolutely out of the world. Is generation. It's called a generative model. And what you're trying to do is you're trying to generate a picture. You write a text and you try to generate a picture out of it. Okay, I'm going to quickly show you a live demonstration of that. So look at this one. What I will do is I want to create a picture of a yellow flower with long petals. Look at this. Okay, guys, why don't you tell me a text? Tell me a text. Tell me what I want. Okay, anybody? Tell me. I'll type something here. This is the generation model. Again, computer vision. You're doing text to image conversion. Red tulip in a garden. Okay, red tulip in a garden. Let's see. Again, it may not be absolutely perfect, but it's quite incredible. Okay, you can add a style, or you may not add a style. All this you can do, right? Generate new picture. Red tulip in a garden. Let's see. Okay, takes a while. It's converting that entire text into a picture. Okay, wow, incredible. Now, this is absolutely incredible. Now, it may not be as per your liking, but there are lots of applications like this today, right? Okay, I'll take two more. I think I'll just take Preeti's the point as well. Beautiful princess with prince in lavender color background. Well, this this is slightly difficult, but then let us see how if this is able to. Okay, I'm not able to copy text. Oh, I think the Zoom copy is disabled. Okay, and you have to type it out. So, anyways, I'll do that. I'll do that for you, Preeti. You ping this to me. So, I think the Zoom the copy is disabled. So I have to type it out in lavender color background. Look at this. Generate images. This is slightly difficult. What is going behind? Well, Siddharth, excellent point. What is going behind the scenes is something using GANs. You can actually read about GANs. GANs basically stand for generative adversarial networks. Okay, this is incredible. No, I know it's not exactly lavender, but I think this is cool, no, isn't it? I know this may not be like the prince and princess we're expecting, but it's fine. It's good for a sample, background or something. What is happening behind the scenes is a generative model. So behind the scenes, technically put, I would say, so instead of yes, it's a generative model. So I would say instead of all the other use cases we were discussing, uh, generative AI, correct, where you're trying to generate something. All along, we are trying to predict something, classify something, detect the bounding box, all that we were doing. Here, we are trying to generate something. You give it a text, you're trying to generate something out of it. Okay, I'll take one last one. This is the one uh, that I think was pinged by Vittel. Vittel, I think is again a slightly hard one to ping. So let's just see. Cyberpunk. I don't know if the machine will figure out cyberpunk. Let's see. Fingers crossed. Fingers crossed. So that's a difficult one you put. Well, I think if you put a normal man, it's still fine. But then cyberpunk, I need to see if it's able to figure out that pattern, because it all depends on the type of label data that you put in. Let's see. Let's see if it's able to work. Yes, it's completely based using neural networks, which I'm just going to be talking about right now. All right. Vital, how about this? Are you happy with the results? Well, even I'm surprised. I'm also surprised. Absolutely, absolutely, uh, floored by the results. Well, artists will not exist maybe a few years from now. Artists are already feeling insecure. Artists have started to learn computer programming now. Because see, we do the same thing with artists, no? Imagine, what do? We approach an artist, we say, hey, design this, design that. You already have generative AI models today where you can write any description, it will generate a painting for you. So it's quite incredible. This is the one more application of computer vision I wanted to show the audience. Uh, we have some other, so the other way around is also there. What I discussed right now was a text to image generation. We have the other way around called image caption generator. Other way around, where we look at a picture and we try to generate text out of it. So we have an image and we try to generate text out of it. So we discussed the other way around, text to image. Now we are basically doing image to text. Very interesting. So image to text is basically referred to as something called image captioning. So what is happening behind the scenes in image captioning? We can quickly take a look at that. Okay, so let us quickly see a small example of image caption generator. So what is happening behind the scenes in an image caption generator? Let us see. So this is basically what we are doing behind the scenes. All of you can see this one. There it goes. This is the image caption generator. I'm going to quickly ping the link to all of you. You can see this. You can refer to this later on in the sessions, and you can see what we are doing. You give a picture of a person, and it generates sentence descriptions from images. It's a image captioning model where you give it a picture and it's able to automatically generate text out of it. You give it a picture and it's automatically able to generate text out of it. And you give it a picture and it's able to automatically generate text out of it. These kind of models can be particularly useful if you're asking me for a real-time use case, that, sir, where is it going to be applied? All this is fun cases we are discussing, right? But what could be a practical application where this is going to be used? Well, I would say, again, Instagram is a great application. Now, we are talking about Instagram filters, obviously. So next time you post something on Instagram, Instagram will not only help you modify your picture, edit your picture, give filters and all that, but it will also help you generate captions. This kind of model can also be extremely useful in for blind people. If you have a blind people who is not able to see anything, the AI model can automatically look at the picture or the surroundings, and it can automatically convert the picture to text. The image to text conversion it can do, because the person is not able to see, right? The person will be wearing goggles, and the model will be automatically able to scan the surroundings, and based on the image, the model will automatically generate text and then do text to speech. It will read out the entire description for the person. I'm not talking rocket science. I'm not at all discussing rocket science. We already have a real-time application from Microsoft that is already implementing this. So people who have Apple phones right now, who are using iOS, who have the App Store, you can go to something called Seeing AI. Unfortunately, Google doesn't have it. I'm actually quite surprised that Google doesn't have a similar feature. But Seeing AI is a Microsoft application. It is available on the App Store. You can download in the App Store. And they have a specific section called scene recognition. So all you do is you just go back and kind of take a picture. You just take a photo of the surroundings in front of you, and it will automatically describe the scene around you. It will automatically describe what is the scene that you're looking at. It's quite incredible how it's actually working. Scene recognition. Very interesting. Scene recognition. So you can try it out. And this is the idea. That turns the visual world into an audible experience. So you have a picture, you're doing image to text, and then text to speech. You can read out the whole world for the person. Right? So quite incredible. Yeah. Oh, absolutely. Yes. The startup case, there are actually a lot of great startups around that. Absolutely. Yes. So this can be difficult. It can be error. It can be prone to errors, but it still works. That's the best part. Okay. These are some fun applications. People can look at a couple. So this is a wonderful one. This is actually Pictionary. This is actually completely using image classification. Just I think just one-off example I wanted to show you. Green bean. Okay, I'm not good at green bean. Okay, let me restart this. Sorry, let me go to something else. Okay, pineapple. Well, I'm very bad in drawing, guys. Okay, let me pick up something simple. Okay, otherwise all of you will laugh at me. Okay, bucket I can draw. I can draw a bucket. See what happens. See what happens. I will start drawing a bucket, and the model will automatically identify it's a bucket. See, I start drawing something. It's a classification model.
I see bread.
Okay.
Or pond. Or swimming pool. Or hockey puck. Oh, I know. It's bucket.
See, ant. Okay, ant might be a little difficult. See, as and when I'm drawing, the model is real time classifying what it is. So this is a wonderful application of Google called Quick Draw. And what it does is based on what you draw, Google is able to automatically classify what it is you're drawing. I don't know if I can draw an ant. Don't laugh at me, guys. Okay,
or
so, I don't know.
or table.
This is
or
okay, over there. Not an ant. Okay. Oh, yeah, I can't draw hockey puck and all that. So let's get into something else. This is quite incredible. You can try out some of these wonderful applications. So this is again completely using image classification to make it work. Okay. All right. This is in fact a wonderful page, and I'll definitely encourage people to go to this page. AI experiments at Google. Wonderful. Since we are talking about deep learning, computer vision, there are some really incredible examples of computer vision that we have here. And one more such example that we have here is AutoDraw. AutoDraw is yet another wonderful use case where AI models are able to help you in drawing something. Right. So again, I'm very bad in drawing, but I'll still try out something. Right. So if you see, I'll try to draw an example of, let's say, okay, just a minute here. So let me just quickly go to. This is the last bit of example I'll show you. We'll get into something else. So let me just quickly show you this one. So this is actually okay. This is really incredible, guys. So as I'm demonstrating this, I'm only feeling very excited. This is really cool. So look at this one. I want to show you an example of a bus. Okay, because I'm very bad in drawing. I think the only thing I can draw is a bus. So let me pick up a bus. Okay, very easy to draw. You just draw a rectangle, and what I wanted to show you is the model is automatically able to complete the picture of the bus. Okay, so it's really interesting. AI assisted drawing. See, again using computer vision, is able to look at your pen strokes. Okay, so I'm going to quickly clear it. Let me just draw this again. So I just draw the contours of the bus. See, it's saying start drawing the bus, and see how it's able to complete it for me. It's already starting to draw the windows, the doors, and all that. It's giving me suggestions. See, my hands are free. I'm not doing anything right now. I just drew the rectangle and it's able to automatically give me suggestions. And now if I give the front porch, I'll give the front portion of the bus. See, it will automatically figure out the thing. See, it's drawn the wheel there. See how beautifully it's working. Okay. And then I will put a wheel here. I'll put a wheel here. I'll put a wheel here. Put a wheel here. Put a wheel here. Okay. Put a wheel here. Okay. And doesn't look like a bus, looks like a tractor. Huh? See, he's drawing the windows automatically. I'll put a door somewhere here. The bus will have a big door. See, and the windows will basically come below it. How incredible! Maybe it will draw some. Okay. I want to draw a three-dimensional view of the bus. Even that I can draw. Okay, how it will look like. Quite incredible. Look at this. Okay, this is actually using AI-assisted drawing. Something that I wanted to quickly ping the audience once again. Really cool. Really cool to see some great advancements of computer vision. Okay, there are a few other things you can also look at. These are some examples we already discussed. If you see, we have got another talking about filters and other applications that even Instagram helps you do. There are some wonderful applications where we can go back and look at pictures. You can look at old photos, and you can basically color them. In fact, many of the old Charlie Chaplin movies, there are wonderful applications where you can go and color these old Charlie Chaplin black and white Charlie Chaplin pictures. Okay, so we can see that these are the old photos that we have, the black and white photos that we have, and how we are able to convert these black and white photos into colored photos. We're able to see that. So we have a black and white photo, and how we're able to convert and change it into a colored photo. Okay, so this is quite incredible, and it is completely working on the basis of CNNs. In case people are figuring out that sir, how is it working behind the scenes? How are these things used behind the scenes? We use something called convolutional neural networks. I already talked about caption generation, where you take a picture and it automatically generates a caption out of it. Okay, this is incredibly hard, but it's able to do it. It's able to figure out. It's an extremely complex thing. It's able to figure out what the objects are, and then it's also able to understand the context to frame a sentence out of it. It's a pretty difficult thing to do, but it's able to implement it. One of you asked me, can we do this with videos? Yes, you can. I wanted to show this example also, but it's actually a lot harder to do with videos. Okay, at a slightly more technical level, if I have to answer the question, videos are just like pictures. Okay, so when I say something like 30 frames per second, 20 frames per second, when you look at a CCTV footage, what is a CCTV footage? A CCTV footage is not an image. It's not a static image. Okay, real time, you're basically getting a video feed. Okay, so real time, you're basically getting a video feed. So CCTV footage is not like a static image. Real time, you're getting a video feed. Collection of images are basically video. Absolutely correct, Preeti. Okay, so when I say something like 30 frames per second, 60 frames per second, 60 FPS, 30 FPS. So when we look at FPS, when we look at frames per second as a as a kind of a guideline. So when we look at frames per second or FPS, something of that sort when we see. So FPS is basically nothing but in 1 second video, we have 30 frames. Okay, in a 1 second video, we have 60 frames. In a 1 second video, we have 60 frames. That means if you have a 5 second video sequence, let's say the video frame rate is 30 FPS, and if you have a 5 second video, then total you have 30 into 5, 150 frames. Okay, so if we have 30 FPS, if we have got 30 frames per second, in a 1 second video, we have 30 frames. If you have a total video duration is 5 seconds, we have total 150 frames. Okay, if you have total 5 second video, we have total 150 frames. So 30 frames per second. So if we have a 5 second video, we have total 150 frames. So 150 images. So a video is nothing but a collection of many pictures. So yes, you can generate descriptions out of it. So all the use cases I talked about, localization, detection, neural style transfer, every single thing can be done even with videos. The only difference is with videos, it becomes a little bit more difficult to do because we are talking about lots of images stacked together overall. Okay, this is a slightly different use case. It's getting a little bit into audio data, but I wanted to talk about it because I was just mentioning about the old Charlie Chaplin films, if you remember. And this is also a great use case where you can go back and add audio to the silent movies. Okay, it's an incredibly hard thing to do, but something we can look at because we are trying to add audio to silent films. Okay, so these are some wonderful applications that I wanted to talk about in the context of deep learning, right? All right, wonderful. Now let's move on. Let's move on. Now we'll get to the next phase of the conversation and talk a little bit about what is happening behind the scenes. What is it? So what are we doing in deep learning? What is a neural network? What is deep learning? And what is the convolutional neural network? We'll get a little technical into the conversation and try to understand a little bit about what is a neural network and and what is deep learning and all that. What we're going to get to talk a little bit about that. Okay. This is going to be a conversation spanning 20 minutes or so, and it will be a little technical part of the topic right now. So what is a neuron? What do we mean by a neuron? A neuron is basically oftentimes referred to as a perceptron. So neurons came about around about 1950s. That was the time when neurons were discovered. And a neuron is a simple artificial neuron is basically a unit which takes in an input, it does some processing, and it gives a simple output. Straightforward. Just remember that we feed in two inputs, x1, x2. We multiply the inputs with the weights, w1, w2. We add some bias, and we get an output y. That is what a simple artificial neuron or a perceptron model basically looks like. Okay, I repeat again. We take in two inputs, x1, x2. It can be anything. I'll give you another more illustrative example in a while from now. We give two inputs, x1, x2. We multiply the inputs with the weights w1 and w2. We add a bias to it, and we go back and do some activation, and we get an output y on the basis of that. That is what we refer to as a simple artificial neuron. Okay. And when we go and stack many of these neurons, this is a simple artificial neuron, a single neuron we are looking at right now. And the term neuron is also inspired by the biological equivalent, exactly as Anangsha also mentioned. Biological neurons also work pretty much the same way. Okay, just in case one of you asked me, the biological neurons are also very similar. So it's inspired from the world of biological neurons also, where we go back and take an input, and we go back and multiply the inputs with the weights, and we get an output. So the receptor signals or inputs are coming from many places. The neuron is able to analyze those signals. It's able to do some processing. It's able to do some activation, and it churns out some output based on that, which goes to the next neuron, next neuron, next neuron, and so on and so forth. That's the pipeline of neurons that you end up building. So when you stack enough of these neurons or perceptrons together in a chain, that layer is what we call multi-layer perceptron or a neural network. So a network of many neurons stacked one on top of each other is what we call a neural network. It's basically called an ensemble of neurons. So here goes a simple artificial neuron, inputs, weight, output. And when we take an ensemble or a collection of many neurons taken together, when we take an ensemble of many neurons taken together, the collection of many neurons taken together is what we call a neural network. Okay, that's the basic intuition. And what I will do right now is I'll demonstrate a very small video to all of you, which talks about neural networks and how neural networks are basically working behind the scenes. And what I will do is I'll be taking a small reference to this beautiful, video by Coursera. I think Andrew NG is something that everybody knows, needs no introduction. It's a very nice video, and I'll be playing this video for the next 4 minutes or so. In fact, it's a 7-minute video that talks about deep learning, neural networks, and what neural networks actually are. It's a very non-technical example. We are not expecting anybody in this masterclass to be aware of the technicalities. Okay, but just to help you understand what is going on behind the scenes, we're going to look at a small 6.5 minute video of what deep learning is, and then we'll go to some more technical details as to what is going on behind the scenes, what are filters, what are convolutional neural networks, and we have some very interesting things to follow over the course of the session today, right? So let's quickly look at this video now for the next 5 to 7 minutes from now. Let's see this one. I'll be also enabling the subtitles so that people are able to understand this a little better. So subtitles will also be on here. Okay. All right.
The terms deep learning and neural network are used almost interchangeably. And even though they're great for machine learning, there's also a bit of hype and a bit of mystique about them. This video will demystify deep learning so that you have a sense of what deep learning and neural networks really are. Let's use an example from demand prediction. Let's say you run a website that sells t-shirts and you want to know, based on how you price the t-shirts, how many units you expect to sell, how many t-shirts you expect to sell. You might then create a data set like this, where the higher the price of the t-shirt, the lower the t-shirt. So you might put a straight line to the data, showing that as the price goes up, the demand goes down. Now, demand can never go below zero, so maybe you say that the demand will flatten out at zero. Beyond the point, you expect pretty much no one to buy it. It turns out this blue line is maybe the simplest possible neural network. You have as input the price, A, and you want it to output the estimated demand. So the way you would draw this as a neural network is that the price would be input to this little round thing there, and this little round thing outputs the estimated demand. In the terminology of AI, this little round thing here is called a neuron, or sometimes it's called an artificial neuron. And all it does is compute this blue curve that I've drawn here on the left. This is maybe the simplest possible neural network with a single artificial neuron that just inputs the price and outputs the estimated demand. If you think of this orange circle, this artificial neuron, as a little Lego brick, all that a neural network is if you take a lot of these Lego bricks and stack them on top of each other until you get a big how or a big network of these. Let's look at a more complex example. Suppose that instead of knowing only the price of the t-shirts, you also have the shipping costs that the customers will have to pay to get the t-shirts. Maybe you spend more or less on marketing in a given week. And you can also make the t-shirt out of a thick, heavy, expensive cotton or a much cheaper, more lightweight material. These are some of the factors that you think will affect the demand for your t-shirts. Let's see what a more complex neural network might look like. You know that your customers care a lot about affordability. So let's say you have one neuron, and let me draw this one in blue, whose job it is to estimate the affordability of the t-shirts. And because affordability is mainly a function of the price of the shirt and of the shipping costs. A second thing that will affect the demand for your t-shirts is awareness. How much are consumers aware that you're selling this t-shirt? So the main thing that affects awareness is going to be your marketing. So let me draw here a second artificial neuron that inputs your marketing budget, how much you spend on marketing, and outputs how aware are consumers of your t-shirts. Finally, the perceived quality of your product will also affect demand, and perceived quality would be affected by marketing. If the marketing tries to convince people this is a high quality t-shirt, and sometimes the price of something also affects perceived quality. So I'm going to draw here a third artificial neuron that inputs price, marketing, and material, and tries to estimate the perceived quality of your t-shirts. Finally, now that the earlier neurons, these three blue neurons, have figured out how affordable, how much consumer awareness, and what the perceived quality, you can then have one more neuron over here that takes as input these three factors and outputs the estimated demand. So this is a neural network, and its job is to learn to map from these four inputs, that's the input A, to the output B. the demand. So it learns this input to output or A to B mapping. This is a fairly small neural network with just 4 artificial neurons. In practice, neural networks used today are much larger, with easily thousands, tens of thousands, or even much larger than that numbers of them. Now, there's just one final detail of this description that I want to clear up, which is that in the way I've described the neural network, it was as if you had to figure out that the key factors are portability, awareness, and perceived quality. One of the wonderful things about using neural networks is that to train a neural network, in other words, to build a machine learning system using a neural network, all you have to do is give it the input A and the output B, and it figures out all of the things in the middle by itself. So to build a neural network, what you would do is feed it lots of data with the input A and have a neural network that just looks like this with a few blue neurons feeding to a yellow output neuron. And then you have to give it data with the demand B as well. And it's the software's job to figure out what these blue neurons should be computing so that it can completely automatically learn the most accurate possible function mapping from input A to the output B. And it turns out that if you give this enough data and train a neural network that is big enough, this can do an incredibly good job mapping from input A to output. So that's a neural network. It's a group of artificial neurons, each of which computes a relatively simple function. But when you stack enough of them together, like Lego bricks, they can compute incredibly complicated functions that give you very accurate mappings from the input A to the output B. Now, in this video, you saw an example of neural networks applied to demand prediction.
Okay, so this is a wonderful demo that we actually saw in the context of what a neural network is actually doing. I hope I'm just going to quickly go back and clarify, and maybe in case some of you found it a little hard to understand, I'm going to just quickly replay. This is a good video, and hence I wanted to do justice and kind of show you the original author instead of me demonstrating it in my whiteboard. So actually, it started off with a very simple demand prediction exercise. I'm just going to quickly explain and then come to CNNs also. So we can see that we are trying to predict the demand based on the price. So the input is the price. And based on the price, we are trying to predict the demand, right? So this is the X-Y combinations we have right now. And that is exactly where Andrew explains what a simple artificial neuron is actually doing. Very nice, very non-technical explanation. One of my favorite videos also, actually. So that's why I wanted to play it out. So this is that neuron that I was referring to. A neuron can accept one input. A neuron can also accept multiple inputs. So we look at a single input. The neuron will do some pre-processing, and based on that, the neuron will give you some output. So in the context of this example, the neuron will accept the price as input, and based on the price, the neuron will predict the demand. That is how the whole thing will basically work out. Let's look at a slightly more complex example, where based on the price, shipping cost, marketing, and material, now you're trying to predict the demand. Okay, so if you think from a general perspective, this is the other way to look at what a neuron is actually doing. Right, so we are looking at the the price. We are looking at the price. Where is that? Yeah, so we are looking at the price, the shipping cost, marketing, material, and based on these 4 factors, we are trying to predict. We are trying to predict the estimated demand. So based on these 4 factors, we are trying to predict the estimated demand. We have the price, the shipping cost, the marketing, and the material. And based on these 4 factors, we are trying to predict the estimated demand. The demand is what we are trying to predict. This is again a simple example of a single artificial neuron, where we have input X1, X2, X3, X4, add a bias. Bias is a standard bias term. And based on that, you're trying to predict a Y. So you multiply X1 with W1, multiply X2 with W2, multiply X3 with W3, multiply X4 with W4, add a bias, and then do a Y. What is the operation going on behind the scenes? What is mathematically what is going on behind the scenes? If you look at a single artificial neuron, like this one, a perceptron model, it's a linear model. We call this a linear model. Why do we call this a linear model? Because the equation is just mimicking a linear equation. So y equal to w1 times x1 plus w2 times x2 plus w3 times x3 plus w4 times x4 plus bias p. It's a simple linear model that we have, right? Now, what is the problem? I'll tell you the problem with a linear model. Linear model is absolutely okay for normal use cases. I'll tell you the problem. The problem is the demand of a product is not directly impacted by the price. The demand of a product is not directly impacted by the shipping cost. The product demand is actually depending on the latent behavior of the customer. Price is not directly impacting the demand. If the product price increases, the customers will start feeling something that will impact the demand. So if I build a simple linear model like what you're seeing right now, we are effectively saying that, hey, price is impacting the demand. That is not the case. Price is impacting something else, which in turn is impacting the demand. That's how we look at the whole thing. So price is impacting something else, which in turn is impacting the demand. That's the way we are going about the whole thing. So price is impacting something, and that is in turn impacting the whole demand. That's the way we are actually going about the whole thing here. And that is exactly where we are looking at the rest of the video, where Andrew explains that, hey, price and shipping costs are impacting something called affordability. This is impacting awareness, and this is impacting perceived quality. These features are directly impacting the demand. So these original 4 features are not having a direct relationship with demand. They are not the direct causes, but we are somehow trying to use the original inputs to create derived features or derived hidden inputs or latent factors, which are ultimately impacting the demand. And this is the crux of what we are trying to do in a neural network. So we originally had 4 inputs to predict the output, that is fine. But now using these original 4 features, we are trying to create hidden features or derived features, which we think are impacting the output. And then Andrew goes on to say that these are called hidden features, although he's giving it names like affordability, awareness, and perceived quality. But in reality, we will not have that. In reality, these are called hidden features, and we will honestly not even know what these features are called. So you'll typically do your neurons in this way. So you'll define an architecture like this. You will have 4 inputs, 1 output. You can define how many hidden layers you have. Right now in this example, we have a single hidden layer with 3 neurons, but you can design extremely complex architectures spanning hundreds of hidden layers and as many number of neurons you want here. So you can do all that stuff, right? In fact, if you want to go back and create a neural network, if you want to see how this is actually working, I can show you a basic example. I don't want to make it too advanced, but you can see a small example here where we have a neural network which is having 2 inputs, x1, x2, and based on that is trying to predict a y. It's a simple use case we are seeing. So it's a simple neural network where based on x1 and x2 is trying to predict a y. You can see that right now. It's a classification problem where we are trying to predict, is it a blue color or is it an orange color, right? So I won't get too much into the technicalities right now, but then if you want to see how this particular model is basically working behind the scenes, you can see how this is going to work out. Okay, so we can add hidden layers. So we can add 6 hidden layers in between, and we can also control the number of neurons. All this we can do in code, but TensorFlow Playground is a wonderful website that Google has. Google has open source this thing. You can go and try out your own architectures. So here goes a neural network where there are 2 inputs, 1 output, and in between there are 6 hidden layers, each with 8 neurons. So 6 into 8, 48. So there are 48 hidden features that we have. And Anansha, absolutely right. You will not know what these features actually are. We will not know that. And we can start training this network, generally speaking. Okay, so people can relate to this example also. This is playground.tensorflow.org. Very, very interesting. And it's a wonderful, wonderful application of deep learning. Okay, all right. Now, getting a little bit into, this is a slightly technical thing, Siddharth. Generally, no. There are some best practices we have in the industry, but generally, no, you still have to try out. If you're telling me that, sir, do we have any hard-coded rules to make it work? Answer is no, but there are some standards we have in the industry. But there are no hard-coded rules as such we have. You have to try out different models, and only then it will work out. Right? Now, deep learning is a very general concept. What I talked about all this while was a very general kind of a concept we discussed. Neural network is a very general concept. It can be used for any kind of data. Okay. Specifically in the world of computer vision, which has been the big focus of today's session, the type of neural network that is used, especially in the context of Instagram filters, like when we talk about filters in Instagram, and what type of neural network is used. What type of neural network do we use here? We basically use a specific type. So what type of neural network do we use for all these photo editing applications, creative photo editing, the filters part that we look at? What kind of applications are used here? What are we doing behind the scenes? When I take a picture, when I add black and white effects, light up effects, doodle heart, what are we doing behind the scenes? Okay. How are we doing this behind the scenes? We use a specific type of neural networks, which is referred to as convolutional neural networks. And what I will do over the course of the next 10 minutes is to give you a little bit of technical theory with respect to what CNNs actually are. What are convolutional neural networks and what are CNNs generally? So here goes one more very beautiful demonstration of CNNs. I will not get too deep into this topic, but I'll just give you a very small summary idea as to what is happening inside a CNN. What are we doing? What are filters? What is a stride? How do we do this a little technically? Might be a little hard to grasp for beginners, but that's okay. Just a very summary view of the whole topic we're going to see. So this is a very specific type of neural network. So CNNs are a very specific type of neural network that caters to images. Neural network we already know. It's a network of neurons that can be used for any kind of data, but CNNs are specifically in the world of images, right? So what are CNNs? What is a CNN and how do we look at that? What is the whole idea of CNNs? Okay. The architecture of CNNs was basically inspired, back by a paper by Hubel and Wiesel. You can read about it. I can just quickly ping you. This is basically how CNNs were initially inspired. And back in the early days, we actually performed lots of experiments on pet animals, pets, like we had cats, we had dogs. A lot of these pets were actually considered for early experiments. So to understand the visual system of mammals, to really understand how humans see things, and to figure out how we can make machines perceive things, we had to first understand how mammals see things, right? Because computer vision is all about making machines see and process something. So to do that effectively, we had to understand how do mammals' visual system is working. And there was a very influential paper by Hubel and Wiesel, where they tried to understand the receptive field for single neurons in a cat's right cortex. How do cats see things? And very interesting, many of the things that they observed, how cats are able to see, that inspired the architecture of a convolutional neural network. So what is happening? What is a CNN? We're going to quickly look at a CNN right now. What are we actually doing in a CNN? We're going to see that. And this is effectively what we are doing, at a big picture level. At a big picture level, we have a picture. We have an image, and all that we are trying to do is we are trying to look at an image as a collection of pixels. These are the pixel intensity values that we have. Just to quickly show you, some of you had this question that, sir, how are we exploring a picture? This is the way we explore a picture. Computers will not see an image like a JPG or a PNG file. So if you give this image to the machine will not see the picture like this. If I open up my paint in front of you right now, let's say I draw the number 8. Okay, I'll quickly draw the number 8 in front of you. This I can save it as a simple JPG or PNG file, right? But what have I drawn right now? If you try to zoom in, you will start to see what it actually is. You start to see the pixels coming to light. Look at this. This is basically what I wanted to clarify. Machines can only work with numerical data. If you have, so machines can only work with numbers. Machines cannot work with unstructured data as it is. So machines can only inherently work with numbers. That's what we are able to see right now. So here also, we are looking at the pixel intensity values. The pixel intensity values can range from 0 all the way till 255. Okay, I repeat. The pixel intensity values can range all the way from 0 to 255, where 0 stands for no pixels and 255 stands for a very strong presence of pixels. So pixel intensity value of 0 means there are no pixels, and pixel intensity value of 255 means there is a very strong presence of pixels. That's what we have right now. So we have the original picture, and we are simply transforming the original picture in this manner, where 0 means there are no pixels And 255 means that there is a very strong presence of pixels. And any value in between means the pixels are vaguely present. Let's say 120, 117, 87, 113, 125. This means the pixels are vaguely present. And this is how we are able to look at it. It's nothing but a matrix of values that we have right now. So 0 to 255, and we are simply seeing a matrix of values right now. And that's the way machines see pictures. We also have a concept of channels. Like whenever we talk about images, we also have a concept of channels. Typically, this is the thing we talked about, right? We look at pixels. We talked about this already. A digital image. Let's say this is the picture we are seeing. We look at a cross section of the picture, and this is what you're actually seeing. A single pixel we have, and a single pixel is basically further broken down into red, green, and blue. That is the way machines are basically processing pictures. So, because what I talked about right now was a simple grayscale image. What is a grayscale image? Grayscale image, the values are always between 0 and 1. Either it is white or it is black or something in between. It's a grayscale. But in colored photos, like the one that you're seeing on the screen, here also we have pixels, right? Let's say we have a 100 cross 100 image right now, and the 100 cross 100 image is basically spanning 10,000 pixels. So you look at each and every pixel, and when you look at each and every pixel, that can be further broken down into red, green, blue combinations. So we can look at the intensity of the red part. We can look at the intensity of the green part. We can look at the intensity of the blue part. We can further break it down into red, green, and blue. And now we are analyzing the whole picture. So any picture that you have can be further broken into 3 shades. If there is a higher combination of red, then the red pixel intensity will be very high, 255. The rest of the intensities will be extremely low. That's the way we basically work through it. This is a very simple understanding of pixel processing I wanted to give all of you. Okay, but there are a lot of things happening behind the scenes. So behind the scenes, we obviously have a lot of different types of things that are happening. And what I will talk a little bit about right now is what is going on behind the scenes when we talk about filters. Right? What are we doing? What are we doing in a CNN? This is how we perceive images. This is how machines see a picture. So when machines see a picture in this particular manner. And a very important concept in CNN is it looks at the spatial context. So if I look at a particular pixel, let's say we look at the pixel 180, we are not only focusing on that pixel 180, but we are also looking at what are the pixels coming in the vicinity of 180. Very important. We are not only looking at what is that particular pixel, because see, when we look at images, do we only look at that one pixel? No, not really. We are looking at the surroundings and then deriving the context out of it. So machines also, the architecture of CNNs are also framed in that manner. We are not only looking at a picture, a particular pixel, but we are looking at that pixel and also the surrounding pixels around it. So this is how we are looking at the whole thing. So whenever we process images, whenever we basically try to understand what is in a picture, we are always looking at a collection of pixels. Okay, and we'll talk more about this convolution operation now. Little bit more technically, what is happening behind the scenes? What is filters? Filters are the most important concept behind the convolutional neural network. And now we are getting a little deeper into the technical understanding. Just 5 minutes more I'll spend on this one. Filters are basically used to transform a picture. You have an original image. You can see at the background, we have a black and white picture entirely. I use a filter. Imagine this is a small microscopic thing that you're seeing right now. Imagine there is a small microscopic thing that you're seeing right now. So all that we are doing is we are just scanning that picture, and we are trying to extract colors out of it. So we have a black and white picture, and we are scanning that picture, and we are trying to extract the colors out of it. That's what we are doing in a CNN. Filters. There can be different types of filters we can add, and different filters can process your pictures in different ways. And how are we basically doing this? We stride through the whole image and we do a convolution operation, a dot product operation. Okay, so we can define different types of filters. We can define different types of filters, and the whole idea is how we are able to stride through the whole picture, left to right, top to bottom, left to right, top to bottom. How we are able to stride through the whole picture, and figure out what patterns are present in different parts of the picture. What are the features that are present in different parts of the picture? Hey, this part of the picture consists of a line. This part of the picture consists of a circle. This part of the picture consists of a red color, something of that sort. That's how we are able to make it work. So we're able to stride through the whole picture, left to right, top to bottom, and we're able to figure out different features of the picture. Okay, that's the way we are able to work it out. Little bit more technically, if I have to explain, I'm going to get into one more conversation before I go to the animation discussion. So what are we doing in a CNN? What are we doing behind the scenes? Let's see that. We have different types of filters, as I say. Different types of filters we have, and what we are ultimately trying to do is we are trying to somehow figure out. You can see the example right now. See how we are striding through the whole image. Look at this. We have the original picture. This is the original picture that we have here. See how we are striding. See how we see. Look at this one. This is -1, 1. That means this is the pattern we are trying to find. Okay, this is the pattern that we are trying to find. This is an edge detection filter. So what we do is we stride through the whole image, left to right, top to bottom, and we try to figure out what are the areas in the image where we are able to find that pattern. So wherever we come here, see how we are able to come. So we are able to find that pattern here. That means in this entire part, we are able to find that particular pattern. -1 means low intensity, +1 means high intensity. So if you look at these pixels, see there's a separation. Here there was no separation. This is completely white, but here there is separation. There is some contrast that is forming in this part of the image. Okay, look at this one. See how we stride through the picture left to right, top to bottom. Look at this one and how we're able to. The vertical movement of the filter will give horizontal edges. Look at this one. This was the original image that we had, and after we did a stride, see this is the filter. The filter is -1, 1, and we have different ways we can define filters. Either you define the filter or the neural network comes up with a filter of its own. Different operations, blurring operation, contrast, saturation, different operations come with different types of filters. This is the edge detection filter. Okay, so all that we are doing is we have a filter which is -1, 1. That means we are trying to identify contrasts. We are striding through the picture left to right, top to bottom, and by doing that, we are able to figure out the edges. See edge detection. See how we stride. We basically get the edges right now. So these are the portions where this particular feature is more prominent. Internally, behind the scenes, we are doing something called the convolution operation. There's a CNN convolutional neural network is used behind the scenes. There's a convolution dot product operation that is happening. And wherever the feature, the shades are more prominent, that is where this particular contrast is present. Wherever the shades are not prominent, there is no contrast. See this part of the cat, there is no contrast. There is no difference that we have. For this part of the cat, there is a huge difference. There is a white pixel, there is a black pixel, there's the edge. And the contrast is very sharply visible. That's the intuition. That's the way how it's actually working out. Mathematically, behind the scenes, this is what we are doing. We take a particular cross-section of the picture. Let's say this is the cross-section of the picture that we take. And we take a dot product of that -1, 1, and we get this particular thing here. That's the way how the mathematics is working out with respect to CNNs. I will not get too technical into this topic. This is an entirely monstrous topic spanning days and spanning many hundreds of hours. CNN is a difficult topic. But then this is also a very nice demonstration where I wanted to show you how you can basically take a picture of a school bus and how you're able to break it down into 3 channels, red, green, and blue, and how you're able to perform the convolution operation to identify the edges. The same thing that we looked at for the example of the cat. See how it's working out for the school bus. Very beautiful. Look at this one. See how the convolution operation is happening for a school bus. I can take a different part of the picture. Let's look at this one. Very interesting. Look at this one. Look at this one. See how the school bus features are basically extracted. We have a 64x64 picture, and the convolution operation is able to identify the edges in the picture. Look at this. This is how image transformations basically happen. And when you transform this picture over many multiples of layers, we get an entirely new transformed picture. That's how CNNs are basically working behind the scenes. Okay, that's how it's working. The only technical idea here is that filters are not handcrafted. Computer vision as a domain has been around for years, decades, in fact. Right? Image processing has been there for a long time. So some of the examples I showed you, like edge filters, Sobel filters, has been there for a long time. We used to handcraft filters. We used to create filters by hand. The thing that has changed dramatically over the last few years is neural networks are able to create filters for us. Because we humans will not know what to identify. Machines are better that way. So that's how CNNs basically work out. Wonderful demonstration. You can actually see how this is working and how the concept of filters are basically working with respect to CNN. This is basically the idea behind different types of Instagram filters also. You can see. Okay, so there are a lot of filters. I know we have talked about generally a specific, very popular kind of filter is called Gingham filter. The very popular filter in Instagram. And what Gingham filters basically do is it reduces the saturation. But there are other kinds of filters also. There's Clarendon, there is Lark, there is Ries, and now we know what's going on behind the scenes. So we have the original picture. The filter is nothing but some kind of a matrix, mathematical matrix we have, and all we do is we strike through the whole picture, left to right, top to bottom, and we're able to somehow process that picture in a different way using a convolution operation. That's what we are doing behind the scenes in an Instagram filter, right? Okay, this is how we are actually working with it. So just wanted to quickly clarify this for all of you. Okay. Technically, we also call it a feature map, by the way. We have the input image, we apply the filter, and we get a feature map. It's just a technical idea of what we talked about here. Okay, so we have the input image. Input image is the cross section of the picture that we take. We strike the filter left to right, top to bottom, and we get the feature map. The feature map is basically the final output that we are getting, the processed image that we are basically getting. And this is the Gingham filter, which is an extremely popular Instagram filter. Just remember that it was founded by Kevin Systrom. Okay, so this is called the Gingham filter. Very, very interesting. It's very, very popular for creating vintage images. So you analyze vintage photos to create a custom image. Very, very popular filter, Gingham filter. Okay. All right, wonderful. Quiz time now. And what we'll do is we'll take up a Kahoot quiz at this point in time. So we're going to go back and quickly make the session of a bit more interactive Kahoot quiz we'll be doing. And the whole idea of the Kahoot quiz is that we want all of you to participate. We want all of you to. It's just a way of evaluating how people took the session, what kind of stuff you and this is something that we also do in our live classes at Alma Beta. We all look at different ways of promoting interactivity. So this is the Kahoot quiz I'll be launching for the audience here. So, okay. Yeah. So okay. I'm going to quickly. Just a minute, guys. I'm going to quickly start the Kahoot quiz here. All of you, please participate, and we have something in surprise in store for you. Just a minute here. I'm going to quickly open it up and. Okay. Just a minute, guys. Just a minute, guys. Just a minute. I'm just let's launching it. Just a minute, please. Just a minute, please. Okay, so yeah, so we have the so we have the Kahoot the Kahoot pin here. People have been asking for the Kahoot pin, so this is the Kahoot pin that we have. So all of you, please uh, you can please go to this link. Just use this link directly, or what you can also do is you can also Just enter into the link, please. You'll also get a QR code that you can also scan. So this is the QR code you can also scan. You can enter into the quiz by scanning the QR code. People can see the screen. So this is the you can also do it from the app. If you're joining in from a mobile application, you can also do it from the app. Or I think it's just easy. You can just directly visit the link that I pinged you. I want every one of you to be please present here. It will be fun to see how far all of you grasp the concepts. So we have 17 people right now who have joined in. How about the rest of you? Quickly. I'm just going to pause for a minute here. All of you, just 1 minute. I will wait. In a minute, I'll start. Just a minute. I want everybody to be here in the Kahoot. Your prizes to be won if people are able to do it well. Lot of good things are in store. Actually, okay. So just a minute more. We'll pause. Neera joins in. Okay. Others, quick guys. 30 seconds more. 30 seconds more. 29, 28, 27, 26. Okay. Quick. 20 more seconds. We'll wait. 15 seconds. Okay, Nilesh joins in now. 10 seconds. Anybody else left out? I will just be starting here. 5, 4, 3, 2, 1. Okay, I hope all of you joined in. Let's start the quiz here. Okay. All right. Okay, what is the Gingham filter Instagram known for? You got a list of 4 options. You can mark the correct one. You can mark the correct one. What it basically does, you can just mark the correct one, like whatever you think is right. I've got 17 answers now. Most of you have answered. Just 2 of you are left out. 8 seconds more left. Mark the one which is the most obvious. Trying to see how far you remember what we taught you in the class today. Okay, great, wonderful. The answers have come out right now. Okay, you can see this is what people have answered. Most of you have answered 11. Okay, most of you have answered 11. 11 is basically it's black aesthetic effect. That's what people have answered. Okay, the correct answer is that yeah. So what are Gingham filters used for? So the correct one is unique nostalgic look. Right, I think we saw that Gingham filters are used for that vintage images, right? There was a part where I talked about vintage photos, if you recall. So it's primarily known for that unique nostalgic look. Okay, if you have not seen that, why don't you log into Instagram today and just try to use the Gingham filter today? I think so. So the correct answer is it's unique nostalgic look. You can see this is where it's marked, and 5 of you got it right. No problem. I know the green option was also kind of a little bit similar aesthetic look, but then it's not black and white. Gingham filters will not make it black and white. Okay. Anyways, some of you got it right. 5 of you got it right. Go to the next one. This is where we stand. Aziz is the leading. Siddharth is second. Yogeshwari is the third. Let's see where it goes from here. Next one. What is deep learning? What is deep learning? Okay, wonderful. I think this is the easy one. I'm pretty sure people have got it right. Excellent. All 24 you have got it right. Okay. I consider myself very successful in my class today. Very good. I'm so happy that every single one of you got it right. I think it's a very easy one. Machine learning technique that uses artificial neural networks for prediction. Excellent. Next one. Where do we stand? Siddharth leading, Yogeshwari second, Aziz third. Okay. All right. Let's see. Next. This is a slightly technical question. As you answered this question, remember there was a part where I talked about deep learning. Okay, I'm very surprised people got it right. That's good. All of you recall that part where I talked about handcrafted filters decades back. In fact, computer vision been around for a long time. We have a lot of handcrafted filters, Sobel filters, edge filters that we manually craft by hand. The -1 example that I showed you was also a handcrafted filter. But deep learning, how it has revolutionized computer vision is that machines are able to generate filters because for complex patterns, human beings are unable to figure out filters. So very good. Most of you got it right. Four of you, six of you answered it incorrectly. Okay. Not vintage photos. To some extent is right, but this is the most accurate answer, I would say. So Aziz is leading. Alex, Hanuman comes in. Siddharth has dropped. So Aziz, Alex, and Hanuman, they are both peaked. So it's up arrow means you're peaked. Very good. Okay, let's see. Fourth question. This is a slightly tricky one. So I know there are very similar options, but then, yeah, see how people answer. All right, style transfer. Style transfer. I think good that we saw a demo also for this particular topic. Most of you answered it correctly, but specifically the question was deep learning algorithm is used in photo editing. Other ones you can be done using simple handcrafted filters also. Contrast enhancement, color enhancement can be done with handcrafted filters. Style transfer is completely done using deep learning. Okay, next. Aziz is still leading, Alex, Siddharth. So they're the toppers as of now. Good. Let's see. Last one. Primary use case of computer vision. We talked about lots of use cases today. Oh my God, to purify water. Whatever you do, don't mark the first option. I think it's a bit tricky. Two answers were very tricky, but yeah, people got it mostly correct. I think it's also pretty much in line with our topic today, Instagram filters. Very good. I think identify and analyze images and videos. It's pretty much yeah. I think second option was kind of similar. Third one, no, virtual reality filters with something entirely different. Second one was kind of related, but I think the third one is more of a superset. So people have again got it right. So I think most of you answered everything correctly. I think except for the first one, most of you answered everything correctly. Great to see. Very happy with the results, and this is where we stand today. So we have the Alma Better team also with us here, and we all know your results. And I think great to see how people have been so participative and people have answered this one. Yeah, wonderful. So well, okay. So okay, yeah. So at this point in time, I'm going to hand it over to the Alma Better team. We have the team here, and I'm going to hand it over to the team to take it forward and to the next steps. So yes, and it's been wonderful having all of you. Thank you for having me. I'm also here, generally, but then I'll pass it over to the team from here. Thank you. Yeah.
Thank you, Sayan, for this wonderful session. It was very insightful. And post going through the Kahoot quiz, one thing which I really liked is that most of the learners understood what you explained to them in the most non-technical way possible, right? The terminologies that you also used, it really attracted me, that curiosity got incremented from my end as well to search those things, post these classes. And that is what we were all expecting from this particular session. That is why I always believe that these master classes give all the students about the insights of the tools that are being used, connecting to the daily life things that we are doing out here. So I will just take another 5 to 10 minutes from here on, because going through this session, a lot of the learners have this curiosity that whether we will be able to use these tools, whether we will be using these applications in the AI modules or even in the neural network wala thing. So I will just give you a walkthrough of how Alma Better basically helps you, because there are a lot of things that you can learn in today's world, but you need a platform where we have mentors like Sayan who can keep on guiding all of you out here, right, regarding all these terminologies and the jargons that are being used. So what Alma Beta does is that, there was one very important question that was being asked, that whether I will be able to learn all these tools and can apply these tools. Yes, you can. And the best part is that you don't need any technical knowledge for that. All right. So what we do here at Alma Beta is that we first of all train you, right? And then we also guide you, because there are like a lot of opportunities that are waiting in the outside world for you, but you need to be mentored to catch those particular opportunities. So what Alma Beta does is that, first and foremost thing, we always believe in peer networking, right? We believe that studying in groups, having talk with all the people who are in your very own batch helps you explore a lot of other insights as well, right? So we make sure that you're doing it right. We also have like a lot of multiple projects, say, and discuss a lot of things in this particular program. But again, how to implement those things, whatever you have learned, becomes very important. To give it a real view, we do have projects that you do in teams, so that different kind of minds come together, and they have different opinions about a lot of questions, a lot of queries that they have regarding that particular real-time projects. And obviously, once you're pretty much ready with all the tools and the applications that are being taught to you, we ensure that you're getting mentored for the industry driven jobs that are available in the market. All right. Sain, do you want me to share my very own screen for this? Yeah, thank you. Moving ahead, that why we need Alma Beta, and the reason is pretty understandable. That first and foremost thing, we always believe that each and every one of our learner need not to have a lot of technical understanding behind them. We teach everything to them from scratch only. Second thing, we have like more than 100 plus live classes, right? And the best part is that all those recorded lectures of those live classes remain with you for lifetime. So, maybe in near future, if you want to revise anything, you want to re-go for any of the projects or something like that, you can just watch the lectures and get yourself there only. We have like capstone projects. It's very much important that whatever theoretical knowledge that you have, you should understand where to use it practically, right? And I always believe that coding is more like mathematics. The more you practice, the more better you become. That is why here at Alma Beta we have like 1,000 plus coding problems and assessments that we have. You will have like weekly doubt resolution sessions, and obviously we will have mentorship sessions where you will be guided towards all the projects, about what career you would be moving ahead, about how you are learning here, and every other thing, so that you remain pretty much focused towards the entire program. Then once complete all the modules, you're pretty much ready to go in this 30 weeks of training that we provide. You will start getting yourself prepared with the career coaches that we have. We have like 50 plus mock interviews for you, so that you become pretty much ready before you're sitting in the real interview. And last and final thing, which is obviously most of us are looking forward to, is that the job guarantee thing. Because whatever we have learned, we need to use it to earn the money, right? And that is why we have like 100 plus job guarantee program with us, with 500 plus hiring partners that we have. So what you have to do, very simple: go to the website, sign up there. You can enroll there, paying a very nominal registration fee. Start your journey, get yourself certified with every module that we have. Post that, you will qualify for the placement services, or the Almax that we pronounce it here, and get yourself prepared for the upcoming interviews that would be scheduled with the 500 plus hiring partners that we have here. Once you qualify for that Almax, you sign the income sharing agreement with us, and your entire registration fees gets refunded back to you. You start your placement program, that is Almax, with mock interviews and every other training session that is there. And finally you land up in your very own dream job, maybe as a data scientist, maybe as a machine learning engineer, maybe as a deep learning engineer. It depends upon how dedicated you are towards this particular program. Now, we have a lot of live lectures. As I already told you, there are like 100 plus live lectures that we have weekly. We have like 4 live lectures, right? Other than that, we do have these master classes where you do get a lot of insightful information about this domain. We have a lot of experiments that we do in that particular 6 months of program that we have. You will have a lot of projects and assignments, and obviously we believe in network peering, so we have like group discussions as well. Now, whenever you're doing a particular course, you need to be motivated, you need to be focused, you need to be well guided. And for that, we have, mentorship sessions, we have guest lectures like that we had like today with Sayan. Then we have like community participation. You can, uh, participate in a lot of quizzes, you can participate in a lot of assessments with the peer groups, or with the students who are already there in your very own batch. So again, it helps you in exploring a lot of other things as well. And then obviously, if you want to qualify for the placement services that we have, you have to ensure that you are completing all your capstone projects, as well as you're completing all your competency challenges as well. We have like 500 plus hiring partners with us, and that consists of both the product based as well as service based companies. A lot of companies are startups as well, like we have like Cred with us, Disney plus Hotstar is there, Uber is there, Flipkart is there. Then we have Ola, Zomato. So they all are like tech giants in their very own field. Some of them are from the finance segment, some of them are from e-commerce, some of them are from the banking segment. So obviously you will have the opportunity to get yourself placed in all these companies, obviously in the field of data domain. No, this is very interesting. This is for the freshers. Most of us are really inclined towards this, that what if I complete my program, how much I can expect to learn. So maximum percent, 37% of the learners out here, they end up getting a salary of 8 to 9 lakhs per annum, which is again a very good start for a fresher. I'm talking about freshers here. If you're already a working professional in the very same domain, you can expect a hike for sure. But again, for a fresher, 8 to 9 lakhs per annum, 37% of the students out here do get that. One thing to note, that 3% of the students also end up getting 10 lakhs per annum. So you have that opportunity as well to start your career at a very good package, because anything above 10 lakh per annum is a very good start for a fresher. And we ensure that you are guided in that way, so that you end up getting that particular placement package. We have our instructors and mentors out here. They are from different domains. Like we have Paras Ahuja, who is from Geo. He is again a data scientist. We have Abhinav, who is from Swiggy. We even do have Sayan with us, who is currently at Walmart. We have Nadul Jan, who is working with us. Then we have Shubham, who is currently working as a manager in the data analytics field for Dream 11. So we have instructors from again both the product based as well as service based companies, and some known technical companies as well, right? Some of the success stories, from where people have started. Most of the learners who enroll here, they are from non-technical field only, and then they get themselves switched into the technical domain, for which they invest their time out here. So we have a lot of people, like Akshara is there, who has become an ML engineer at JP Morgan and Chase. And again, we have Soumya Jan, who got placed at Paisa Bazaar. Then we have Kamya Malhotra, who got placed at Novartis. So we have like multiple people. You can even find all these stories on our website and get yourself go through all these stories to understand that how Alma Better is giving all these people that transition for which they're looking forward to. Now, it's very important to go through the student dashboard wala thing, because once you get yourself enrolled, it's important that you understand how to actually use it, right? Because most of the learners, after enrolling in the program, find themselves in a situation where they have a lot of things to access, but they don't actually have that kind of a flow, how to go through it. So I'm just sharing my screen here. I believe you can see this is how the dashboard looks like once you enroll with us. So we have like the syllabus part here, where we start with a program orientation. You will have certain aptitude classes as well, and we talk about how you need to keep your learnings out there and every other thing like that. Then we have like our first very session, that is with Python. And when you start, you click over it, you will have a lot of things out here, right? You will have the lecture out here, which you can watch. Obviously it's the recorded one. Live one has already been done. Then you have the Google Colab with us, as already been discussed by Sayan in the session, where you can do all the programming stuffs and every other thing, and you will have your notes as well with you. If you just go through this once, look, this is where you will have your notes. It all starts with a very basic thing, introduction to Python, why we need Python, every other thing. So what you can do is that you can have this Google Colab with you, where you can practice also, and also you have the notes of the topics that's being done on that particular day. Then we will have quiz every day. We will have like 8 to 10 questions where you will be completing your quiz. And other than that, you will have your feedback form as well, where you can share your feedback about that day's instructor, so that we just keep on improving with our lectures. Now, today, what we're talking about, we have like 4 to 5 modules here, where we have like Python programming that will be taught to you. Then we will have Python control flow. Then we will have our OOPS programming. And then we will go to the DSA part that becomes very important in most of the product-based companies. Now coming to the numerical programming, in the part we have like multiple libraries that you will be learning. That will be Panda and NumPy for sure. Then you will have a lot of projects as well. As you can see, there is a project as well by the time you finish this particular program. Then we will have the relational database where you will learn about the SQL language, right? Obviously, Tableau is a very important part. We will have that. We will have Excels as well. We will have Power BI as well. Now, the one important thing is that going all through these sessions, you will have like some topics or some modules that will be specialized in a particular segment. Like today we learned about deep learning, so you can select that particular topic and can learn about it, how neural network is working here, deep learning part 1, that is part 2, part 3. So you will deep dive into this particular mechanism with all the assessments, the quizzes, as well as with the projects that we have. So you will somehow enhance your I would say fundamentals going through all these lectures and the modules. Again, if you're going through certain modules, it's also becomes very important to have a practice of it. So we have like, multiple coding problems. You can just click on any of them and you can start solving it here only in this Google Colab that's been given to you. You can submit it, you can run code, you can check what could be best done here. If you do it well, again, obviously you will moving ahead for the next couple of tasks that we have. If you're not, if you fail to do it, obviously you will have your answers out here, right? Where you will be also getting certain hints. Then after submitting this, entire question, you will get your assessment here as well. So you can have the practice, and we just keep on adding a lot of questions here as well. Then we have like projects with us, the telecom churn analysis, the EDA topic, which I already told you in the Python section. Then we have like global terrorism data set. So we have like overall 31 projects, out of which you have to make sure that you're completing at least 5 projects to qualify yourself for the LMAX or the placement program. So in the machine learning module, we have like projects from Netflix, we have it from Zomato, and we have like multiple projects out here, which would be done in groups by the learners, in that particular batch. Once you qualify for the placement services, once you have completed all these modules in these 30 weeks of program, then we will try to give you some more add-on informations before you start preparing yourself for the interviews. Obviously, you will be going through a lot of tests which you have to qualify, and then we will ensure that we are preparing you for the interviews. You can book a mentorship session also here. Let us assume that you are just going through one of the topics named supervised learning, and if you felt like that you need certain guidance in that particular topic, or maybe in that particular project, you can just add any date, time, depending upon your availability, and you can book a slot out here with one of your mentors, right? And you can have a discussion with him for like 30 minutes, 45 minutes, one-on-one, to clarify all the queries that you have regarding that particular topic. You can do the very same thing if you want any placement guidance, or if you want any learning guidance, if you want any capstone project guidance, obviously you can book a session from here as well. In case you are learning, few of the topics and you felt like that you're stuck in any of the problems, or you felt like, you need certain help, you can just type your questions out here. What are the things that you want to understand, or something like that. We have like a lot of questions already being posted here by the students, so you can even take the recommendations of them as well, right? All you can do is that you can post your very own question out here as well, and can drop it here only. The support team will make sure that your question is being getting answered in the limited time. All right, a lot of questions already being posted by the learners, that what will be the LMAX eligibility criteria. There is the answer for that. You can even recommend this, refer it here as well. What is LMAX batch announcement? And then there is a lot of batch issues or something like that. If you go into the data science segment, you will find out that facing problem in importing CSV file from my system. So again, it's being sorted out there only, right? So this is what we do here at Alma Beta. We ensure that your learning goes as smoothly as it is possible. If you have any other topic, you can just post that topic out here. You can question your topics out here only, right? You can log in there directly and can post your questions as well. Again, a very important part is this community part. Again, if you are learning in an organization, it's always better to have yourself forming a network with the people who have already been, doing this particular program with us, or who are already our passed programs, right, who have passed out this program. So you will find a lot of people out here. You will find your instructors, you will also find your mentors out here. Even the placement team is here, and all those peers who are learning with you are also here. There are multiple groups also that we have, like chill space, because obviously when you're learning something, you need some space for keeping your mood refreshed. So most of the learners, they just share their memes, some of their recordings out here, so that you can just refresh yourself and get back to the study part as well. So this is what the chill space is all about. Now currently we are in the cohort pair wala thing. Upcoming batch is already coming, upcoming Tuesday, but this is for the previous batch that we have the last week, right? And you will find out the group members out here who are joining this group, and this group members consist of all the instructors, mentors, along with the students that have enrolled for that particular batch, along with some of the student subject matter experts as well, right? So we have this cohort last week only, that was on Tuesday, this week only Tuesday, and now we will have an upcoming batch that will be starting from the upcoming Tuesday, that is the data science batch from 18th. So yeah, that was it from the dashboard part. Now one more thing, since we have completed the dashboard wala part, this the surprise for which you all were waiting for, that you can visit our website once, and I want all of you to note down this coupon code, and you can use this coupon code to get yourself 35% off on the price that we are taking for the registration fee out there, okay, which is 29,999. And you can use this coupon code out there, and you will end up getting a discount of 35%, and that entire course will charge you around 19,499, which is completely refundable fees once you qualify for the Alma Expert. All right, so you can use this coupon code. I'm even writing this down in the chat section as well, so that you have this with you post this particular program. So someone is saying that what is cohort? Cohort is nothing but it's just the batch name. We have like multiple cohorts, like cohort Paris is there, then there is upcoming cohort named Delhi. So it's just the name of a particular batch. All right, perfect. So that's the coupon code that you can use. Now it's time for the Q&A session. Now, if you have any doubts regarding the admission process, I'm more than happy to solve it. So if you guys have anything that you want me to answer, you can just drop your questions out there, and I will be, answering them in the next 4 to 5 minutes, and then we will be wrapping it off. Yes, it's like a Paris cohort, and then there is like Delhi cohort that will be coming in. So cohort is just the name of the batch. Do we have any other question out here regarding the admissions or regarding the program that we are offering? All right, I can see that we don't have a lot of questions. Obviously, once you complete your particular program, the training program that we have here for 30 weeks, we will start first of all with the mock interviews, and we will ensure that you're getting 100% placed in one of the 500 plus company partners that we have out here. All right, everyone out here, you can even visit our website, Alma Better, for yes, you can complete that particular course in less than 30 weeks, but that depends upon how disciplined you are. And again, I am telling you, it's all about the dedication, the discipline that you will show. So if you have any other further doubts, what you can do is that you can visit our website as well. You can even have a request call back with one of our counselors who will give you further more briefing about the offerings that we have, right? And yes, shift the name. You can get a placement before 30 weeks. It's pretty much possible depending upon how disciplined you are. So that is it from the session. I have already pinged the coupon code for the 35% discount that you will be having. I'm pinging it again. Just note it down. You can directly go to the website and can apply this coupon code to get yourself 35% discount over there as well. Thank you, all of you, for joining this session. It was great having you out here. I really appreciate your patience. And thank you so much, Sayan, for your time as well for here. It was definitely a very exciting and a very insightful session. And till then, it's a goodbye from myself, Manjul, and from the team Alma Better till the next masterclasses, are being scheduled. The prizes will be shared you via mail, Alex. Don't worry about that. So the certification and the prizes will be shared you via mail. Nothing much to worry about that. Thank you. Thank you so much, guys. Have a very good day. Bye-bye. Bye. Take care, all of you.